Exciting for this for the last day in Devcon talk. We have scaling privacy with Nightfall and Starlight. We are having two speakers. The first one is Chaitanya Koinda. Okay, I'm Paul Brody. Please come. Please come and introduce yourself.
I'm Paul Brody. I'm the global blockchain leader at EY. I'm delighted to be here. This is my third DevCon, and it's very nice to be here on the last day without like a little typhoon bearing down on us as well. So I only have a few sessions. I want to give all the time to my co-star Chaitanya as much as possible. I want to take just a couple minutes to talk about, a little set this up, right? And you know, it's good to see the hearty crowd here, 10 a.m. on a Friday morning, right? That's not when you expect most people to be fully awake. So, what is the point of privacy, right? Financial and industrial use cases, privacy is fundamentally essential, right? I think, you know, we talk a lot about the value of privacy in the world of blockchain. We don't actually do a lot about it, but if you serve large companies, as we do if you enterprises, what you'll discover pretty quickly is that most of the things that enterprises do aren't suitable for fully public consumption, right? They don't publish their contracts. They don't tell people how much they're buying. They do in the aftermath, right? They publish their financial statements, but they won't tell you in advance exactly what's going on at the time. And they don't want to disclose what they're buying, how much they're paying for it. So privacy is really essential. And one of the things that a lot of people don't realize is that you really need actually two kinds of privacy. You need one kind of privacy, which is to represent digital assets or physical assets, the tokens, right? But then you need a second kind of privacy to represent the business agreements that move tokens between enterprises, right? At the end of the day, every business agreement boils down to one party has money, the other party has stuff, and they're exchanging them under the terms of some kind of agreement, right? So in theory, if you can represent the money and the stuff as tokens, and you can move them around with privacy, and you can represent the business logic, the rules of that exchange with privacy, then you can pretty much manage and operate any kind of business process on a public blockchain. And for those of you who don't know, at EY, we are fanatically committed to public blockchains, right? That's really not just public blockchains, but very specifically to Ethereum. We only build on Ethereum. Right? We only build on Ethereum, we only build on public blockchains. That's been our policy for many years now. We've got one piece of this puzzle. It's called Nightfall. Nightfall allows you to move tokens around. It's currently in beta on the testnet. We will be in production one way or another at some point in the very near future. And that allows you to put things into a shield contract. In the sense, it's a little bit like Zcash, but for any kind of fungible or non-fungible asset. The second thing that we're building on, and the thing that my colleague Chaitanya is going to talk a lot about today, is how is both the combination of Nightfall and Starlight. And you're mostly going to talk about Starlight, right? Right. So Starlight allows us to do something pretty useful and clever, which is to make business logic private on the public blockchain. And this is the really hard thing. We spent a lot of time thinking about this, right? It's really hard to teach developers to use Socrates. How many of you use Socrates? It's hard, right? It's really hard. But there's an easier way, which is, what if we could make a compiler? So you could just mark up a standard Solidity smart contract and then recompile it as a zero-knowledge circuit. And then you could run it on the mainnet or on a layer 2. Then you would have a really simple, straightforward way and a scalable way to have secure private business logic on the public Ethereum ecosystem. So that is our strategic goal. It's nothing short, in my opinion, than trying to completely transform how the entire world does business by moving enterprise transactions from private blockchains or private systems onto public Ethereum, but with the kind of privacy that enterprises need. I just want to close out by saying that both Nightfall and Starlight are in the public domain, right? We're a large company, so people are sometimes a little suspicious of what it is we're doing, right? Everything that we have done is in the public domain. We have relinquished our ownership rights to it. It's not just open source, it is fully public domain, right? And so there's a lot of stuff that still needs to be done. We are always looking for help in this. We are trying to build a true open source ecosystem around industrializing and scaling privacy. With that, I am going to hand over to the true star of this presentation, which is Chaitanya Kanda. She is one of the heads of our research organization and has been working on both Starlight and Nightfall for 6 years now, I think. Yeah, 6 years. Like, that's real effort. Chaitanya, please.
Thank you, Paul. I'm Chaitanya, and I work in EY's R&D team as an applied cryptographer. Before we begin, I'd like to mention Miranda Wood and Swati Raval, both of whom are not here today to present this, but have been putting immense work and effort to bring it to where it is today. Now, moving on to Starlight, the topic of a conversation. What Starlight is it was born out of frustration, out of 6 years of research within EY. We've been working on zero-knowledge proofs for quite some time, and we've learned quite a few lessons from it, right? Trying to build private applications for businesses is not an easy task, because what you have to do is come up with protocols that turn your business logic into private logic, and then turn them into circuits. Now, in order to do that, writing circuits has a very steep learning curve, and an everyday developer, to be able to do that, it takes quite a lot of time for them to learn it, to begin writing the circuits to begin with. That is just not practical, because as EY, we need to be able to churn out private applications at a much quicker rate than the developers can actually learn. And that's pretty much one of the reasons why Starlight was born. But in order to do that, you now need people who are experienced in writing zero-knowledge proof circuits. That in itself is another problem, because the number of people who can do that today is very, very few. That was literally how Starlight was born. We thought, okay, we're going to solve this problem because we need to scale much faster to create private applications, and Starlight lets you exactly do that. The other thing we've only realized after actually building this application is that it did something a lot more crucial. In order to build private applications now, it's pretty much instantaneous. In the fact that the amount of time it takes you to create private applications is the amount of time it would take you to write a Solidity smart contract and modify it a bit, and that's it. Instantaneously, you have private applications ready. Most importantly, what we've also realized within R&D is that as a bunch of people who were hired to be smart and to do smart work, we've not done very smart choices, because essentially what we've done is we automated our jobs. What do we do now? Well, sadly, I think Paul heard that today, so he might or might not have realized that until now, but there's no going around it anymore. Very smart again. Now, how does Starlight work? You take a Solidity smart contract, and we picked Solidity because it's the most popular programming language that blockchain developers know today. You take a Solidity smart contract, and then you mark certain parts of the smart contract private, and then you create this other contract called Solidity smart contract, or zero-knowledge proof compatible smart contract. And you take that decorated smart contract, and when you call Zapify, Zapify stands for Zero Knowledge Apify, private Apify is pretty much what it conveys. So when you run Zapify command, the transpiler, which Starlight is, will churn out a fully working private application. Now, just to dig a bit more deeper into what that private application looks like, essentially what you have are contracts that hold the private business logic in terms of proof verifications, and then you have circuits which have a bunch of statements that you then have to generate a proof with. And then you have what we call Timber. Now, Timber is another EY product that is actually one of our best work, in fact. What Timber is it's a Merkle tree that holds as its leaf nodes, commitments to values that you would like to have private. And the best part of it is that on chain, all you store is the root of this Merkle tree. You're not storing any of the leaf nodes, none of the commitments, but you also store what we call a frontier. Now, frontier is a bunch of nodes at various heights of this tree, which is used to compute the root in a much more efficient way than you can traditionally compute today in a Merkle tree. And the leaf nodes, which hold the commitments, the intermediary nodes of the Merkle tree, and the root itself are held inside a local database, which is listening to the blockchain events from Timber. So that's what Timber does. Timber holds a list of private states, essentially. And then you have a blockchain client, which will be used to do transactions of Starlight. You use a blockchain client to send those transactions. And then you have Socrates. Now, Socrates is a tool that lets you create write circuits, compile them, create trusted setup of these circuits if you're using a trusted setup related SNAR. And then you can generate proofs with it, as well as do off-chain verification, which is not too relevant for us because we do on-chain verification. And then finally, we also create tests, end-to-end tests that show the entire application or private application working. So it has to call the contracts, generate the proofs from the circuits, and then give you the final end state. Now, what it is that we do by taking a plain vanilla Solidity smart contract, you need to use certain keywords to specify what parts of logic needs to be private and what kind of business logic do you actually want to hide. And in order to do that, we have 3 keywords that we use. The first one is secret. So secret is used on any state variable that is meant to be private or the value of which has to be confidential. You can apply secret to state variables, to function parameters, to functions also. It's a work in progress as we speak. It's a future enhancement. But you can't apply it to local stack variables inside functions themselves, just because that comes under business logic and not really any state that you're storing. The way it works is that we use this cryptographic primitive called commitment, which is both hiding and binding. So any value that is held inside a commitment is not visible to the outside world, only visible to the people who can open the commitment, and it's bound to that value too. So you have to create a commitment of whichever it is that the state variable that is declared as secret. Now, to take a quick look at the example here, you have a very basic example. You have a state variable called x. You declare that to be a secret, so which means any value that is held inside X has to be secret to the outside world, can only be visible to the owners of that commitment. And then you have a function called add, which takes in as its parameter a variable called y, which is also meant to be secret. So what add does is it increments the value of X by an amount of y, and both X and y have to be private, so nobody should know what X holds, and nobody should know how much it was incremented by. That's pretty much what it does. We'll come to known in just a moment. So the next keyword that we have is called known. Secret state variables are useless if all they do is hold the variable and do nothing. What you need to be able to do is to actually make changes to these variables. You need to be able to update them. But the question becomes, who can update them? Should it be the owners of these commitments, or should it be other people too? And there are instances where you need both of those situations. So you need to be able to differentiate between the two. And that's where known comes in. So what known does is it takes the state variable, and it will only let the person that can update this variable to be the owner of that state variable. So nobody else can make changes to that variable. So the kind of changes you'd make is essentially incrementation statements. And the way it works is also very important. what you would need to do as the owner of a commitment is that show a proof of knowledge that you own this commitment by opening the commitment using the secret values to the commitment that only you would know. And then you would have to show the existence of that commitment in a Merkle tree, not by pointing to it, but by actually not pointing to it by using a sibling path from the position of the leaf node and calculating the Merkle root from it. So that just does not reveal which commitment you're actually using. Then you would actually have to show that you can change that commitment by proving that you know the secret key of the public key that is used within the commitment. And that public key essentially refers to the owner of the commitment, right? Then you will have to nullify the old commitment by creating a nullifier. And then you would have to create a new commitment, which holds the updated state, which is x plus y in place of x. So that's the entire logic that's happening when you declare something as a known. On the right, you see the exact same example as before. The only difference is you would see that x plus y, x is equal to x plus y is defined as known. Essentially what you're doing is you're creating all of these statements, which will then be generated as proof, and the only person who can create that would be the owner of the commitment to begin with. And then you have unknown. Now, unknown is the opposite of exactly what known is. So known was someone who owns it making changes to it. Unknown is someone who does not own this commitment, should also be able to contribute to the value of that state. The way you would do that is we have this concept called part commitments. Essentially what part commitments are, they're a part of the entire state of the secret variable. So if you want to know the exact value of that secret variable, that does not come from one commitment, but it comes from the summation of all of the part commitments. And these part commitments themselves can be seen as UTXO-like nodes that can then be individually used to move around. So that's what part commitment does. And to take a quick look at how that will work, we have an example again here, a slightly different example. You have a secret variable, which is called balances, which is a mapping. It's a mapping from addresses to the balance amount. You have two functions. One is deposit. Whoever calls deposit is going to be able to increment their balance by the set amount. And then you have transfer, and whoever calls transfer will transfer a certain amount from their balance to somebody else. What I want you to notice here is that just the yellow bits of the code. So you're declaring balances to be secret, which means you want no one to understand whose balance is how much. And then you have the function parameters amount and recipient to be secret. So if you were to do a transfer to a certain user, a recipient, and by a certain amount, we want both of those to be secret too. So those will become private inputs to your proofs. Finally, the last statement where you see unknown balances, that's the other bit. So the way unknown works is by creating part commitments. And that particular statement, you will notice that you're incrementing the balance of somebody else, not your own balance. That's why you need to frame it as unknown instead of calling it known. And the compiler will be able to create part commitments instead of throwing an error at you. Very quickly, I keep talking about commitments. Just want to talk about what commitment actually holds. For your normal variables, commitment holds four things. It holds the state variable ID. Every contract has a list of state variables, and then each of them have an ID. And then you have the value of the state variable, and then the public key of the owner of the commitment, and a random salt, which is required for the hashes. Now, well, you can't see what's happening there, but I will tell you it's this mapping kind of state variable, which holds balances that are mapped from address to the balance amount. So essentially, in that situation, there's a slight change where the first part of that hash has the state variable ID and the mapping key, which in this case will be the address of whosever balance it is. And you hash them together, and that becomes the first part of the commitment structure. That is literally how the commitment structures work. Now, in terms of the various steps that we go through to actually have the completed private application, these are the steps. First, you will take the Solidity smart contract, which is the Solidity smart contract with the keywords added to it by the developers. You then syntax verify it. There will be various cases where the developers would not use the keywords the right way, and you'd have to be able to throw errors and warnings at it. And Starlight is smart enough to be able to show that. Then, the first step is to actually remove the keywords that you added, these three keywords, and you will have a plain vanilla-looking Solidity smart contract. You take that contract, run it through a Solidity compiler, and it outputs an ABI.json file, which essentially is the syntax of the various state variables and functions that this contract holds. Now, it's a JSON object of the nested type. But essentially, you can parse it as what we know as abstract syntax tree, an AST. So what abstract syntax tree is, it lets you take any program and split the syntax of this program into a tree. In the case of a solidity smart contract, you would have your contract at the very top, which will then be split into state variable declarations and function definitions. The state variables will then be split up into the type of the variable and the value of the variable. And the function definitions will be split up into the type of the function parameters, the return parameters, and the body. The function parameters and the return parameters will be split up pretty similar to the state variables between the type and the value they hold. And then the body, which is the important bit, is going to be split up into the kinds of statements that can exist, expression statements, assignment statements. So you will have the operation on one end with its children node being the left-hand and the right-hand operands of this operation. So that's how your abstract syntax tree would normally look like. So you take that tree now, once it's generated from the ABI.json, and then you put back the keywords that you used originally in the solidity into this tree. So if a variable was secret, into its type, you will now say secret type variable. Now, from this modified abstract syntax tree, you will have to generate 4 different output files, the files being circuits, contract, the orchestrator code, and the test code. Before generating that, you will actually have to create 4 different kinds of abstract syntax trees, which will represent what the code should look like in files from this original abstract syntax tree. And from those abstract syntax trees, you will then generate the code files. That's pretty much how it works. Sounds simple. The code is painful, I tell you. Now, just to give a quick idea of what the architecture looks like, you would have your ZOL contract, which has 3 functions, all of which has secret variables that it manipulates. Then you will have the orchestrator. The orchestrator holds the API. Essentially, a user will call the API, and the API will have an API endpoint for each of those functions. So once you call the API will then orchestrate by interacting with the proof generation or the contracts accordingly. Now, orchestrator can also do setup for your circuits, which generates the private proving keys and the verification keys for these circuits. And then it will also deploy the required smart contracts onto whichever blockchain you're using, but in this case, we always use Ethereum pretty much. And it will also deploy the verification key into the verifier smart contract. And then it also holds a database of the commitments that pertains to the user who's using this orchestrator, as well as the secret information that is required to open the commitments. It will also hold keys, which suggest about the ownership of a commitment. All of this, of course, can be re-architected a bit more for production scenario where you're storing this information much more securely in a HSM, wherever you'd like. And then you will have the smart contract. You have the shield contract, which is the contract that gets called when somebody wants to do one of these functions, which will in turn call the verifier smart contract to verify the proof that you've just submitted to it using the verification key that is relevant to that verification. And then you will have the timber tree that we just spoke about earlier. All it holds is just the root. That's why you see it in yellow. The rest of it's not really held inside the smart contract, cost purposes. And then you'll have the Socrates, which holds the proving keys, the circuit files, which will help in the generation of the proof for each of these different circuits. And then you would have the Timber-Merkle tree, which holds all of the nodes of the Timber-Merkle tree itself. Now, we're almost the final bits. So giving a quick example, here we have an invoice smart contract, and the secret variable in this case is invoice, which is a mapping. It holds against an address how much invoice is owed by that address. Now, you have 2 different functions, add invoice, pay invoice. The way add invoice works is that somebody who wants to invoice party A that wants to invoice party B will add to party B's invoice, pending invoice amount, the amount they should be invoiced by. So that's why you will see that I am invoicing somebody else, so I'm setting their state, so I'll have to specify unknown. That's pretty much what's happening here. And then when pay invoice is called, what it essentially does is I will pay my pending invoice to whoever I'm supposed to pay, and while doing that, I have to reduce the amount owed in my invoice amount owed state variable by the amount I paid by. So that's what pay invoice does. Now, just tracking through the various steps that's going to happen is, you have on Solidity smart contract, which will spit out all of these different bits of logic. A user will first call add invoice API because they just want to add an invoice. And when that happens, immediately the orchestrator will look, oh, should I fetch a commitment from inside my DB or not? In this case, because I'm adding an invoice to somebody else, I don't have any of my commitments that I'm spending. I'm just creating a new commitment for somebody else with their public key as the ownership. So I'll just be creating a commitment from scratch. Once that is done, the orchestrator will then have to speak to the Socrates, asking it to generate a proof with the private inputs and the public inputs required for this function, using the private proving key of the add invoice. Once that is done, we get back the proof to the orchestrator, and the orchestrator will then speak to shield contract by calling the add invoice function. The shield contract, which in turn will receive this proof from orchestrator, will have to call verifier contract to verify that bit of proof using the relevant verification key of add invoice. And on successful verification, we update the state by adding the commitments to this Merkle tree, and the root is updated. At which point, the Timber tree, which is a Timber container, which is listening to the Timber events off-chain, will receive the latest commitment and the roots, and then it will store that within itself. So that's pretty much how a private application would work. And in order to build this entire application, all a developer has to do is to write a Solidity contract and add some keywords, and then call a transpiler. That is pretty much it.
Thank you, Chaitanya. And I will just add one final message, which is if you want to play with this stuff, it's out there on GitHub. It's github.com/EYBlockchain. It is free. It's open source. It's maturing quickly. I think we're in a pretty good beta now, and it's getting better by the day. So please go try it. Make zaps. And please use our phrase zaps. Do we have any questions? Or just gratuitous flattery? Yes, you, sir.
I just want to say this project is super awesome, one of the most exciting things I've seen here at DevCon. Now, I did notice on the GitHub there's a lot of disclaimers everywhere, basically saying, please, please, please don't use this in production. I just was curious, do you guys have a roadmap, or what are your thoughts around when you think it'll eventually be a little bit more mature and ready for production applications?
These are disclaimers that we are required to put there based on the advice of our attorneys. I mean, I think we are. I mean, we will say when we think we're sort of at version 1.0, right? And we encourage people to test and play with it. But and we will probably get some third-party verification as well. But fundamentally, we do we can't tell other companies what to do, and we certainly don't want to be responsible if things go wrong, which they always do in software. So
thank you for the talk. So one question: is there a way that two private keys can really reach the information at the proof? So in that sense, you always have been figured out that at the balances, for example, the only one looking at his own balance was the address who owns the balance. So is there a way, for example, is there a regulator or somebody who needs to have all the access to all the proof to be included in the information?
You mean to say if a commitment can be owed by more than just one key? Well, ownership is just always with the one key. And ownership is defined as not whose key there is inside, but also actually the knowledge of the commitment. If you wish to share the knowledge with more than just one person, either of them can now spend that commitment. So if you'd like multiple parties to be able to spend a commitment, you just share the secret information with them. That's what makes them the owner.
The other sense about events, so now we are saying state, but
Yes.
it doesn't make sense to include the events in this known, unknown, etc.
So as part of events, you're not actually revealing these secret variables at all. All that gets sent out as part of the events is commitment, which is hiding such that no one can actually see what's inside it anyway. And then nullifiers. Those are really what will be the variables that events transmit.
I think we have time for one more quick question, and then we're going to be yanked off stage.
This is definitely great. So nothing binds it to just Ethereum. It is any EVM-compatible blockchain. This should work, right?
Well, it spits out Solidity smart contracts. Obviously, it's in the bytecode that is required for Solidity. So in that sense,
EVM.
yes. But if you want to hack it to something else, you literally have to change the code such that it spits out the bytecode that's relevant to whichever blockchain you'd like to use it for.
Okay. So that's one. And the second thing is, like, if you want to optimize for, like, let's say, proof size or verification time or whatever,
yes.
Groth 16 versus Blanc or what, where do we set that up?
So the proof itself is generated by Socrates. Okay. As long as the proving system that you want is supported by Socrates, you can actually have it generate the proof in exactly the proving system that you want. I don't think Planck is currently supported by Socrates, so you wouldn't be able to do that, but I'm sure they're looking to add it.
Thanks.
Awesome. Thank you, everybody. Have a great day.
Thank you, Paul. Thank you, Chaitana. Well, our next talk is ZK budgets, and our next speaker is Adrian, the founder at Sismo.
Next is here.
Please, Adrian.
Hi, everyone.
And please give them a round of applause. Thank you.
Hi, my name is Adrian. I'm the founder of Sismo, and I'm excited to speak today about ZK badges that are a new primitive for you to leverage fully your on-chain data, your sovereign data. So this talk will cover the notion of sovereign accounts, self-sovereign identities. But before getting into that, I'd just like to spend a few words about Sismo. We started Sismo because we are concerned about the centralization and lack of privacy of our current social tools and digital identities. We think that there's too much power in the hands of big companies holding our personal data and in governments that can access it at will. And so what we want to do is really to add a privacy and decentralization layer in identity systems so that we remain sovereign. We want to protect human sovereignty, meaning that we want to be sure that individuals remain in control of their societies and that we keep on check the central entities that are public or private institutions. So what we do is build primitives to empower our self-sovereign identities. So the first primitive that we built are ZK badges. They allow you to leverage your sovereign data. We'll see that later, but they are soul-bound tokens. They are non-trustable tokens that are attestation, meaning that when you have a ZK badge, it means something about your identity, your data, your reputation, your history. They allow you to do three things. First, they allow you to import reputation from an account to another. Let's say that I have a punk on an address, and I want to prove that on another address, have an attestation. I get a ZK badge on a new address, and I'll have the proof that I have a punk. It also allows me to selectively reveal what I want from my accounts. So granularly reveal some personal data. Let's say that I have an account with a lot of data. I'm able to pick one piece of data, let's say the CryptoPunk ownership, and I'm able to reveal that to someone. I own that, without giving my address or anything else. The last thing is it allows you to aggregate your data. Let's say that you have a punk on an address and a punk on another one, and you'd like to prove that you have two punks without creating a link between your accounts. That's what ZK badges allow you to do. So it allows you to control your identities and without creating links between them. So now I think that before getting into the technical part of the ZK badges, I'd like to spend some time on self-sovereign identities. And because that's what badges are for, we built that. Our goal is really to, with ZK badges and generally with Sismo, is to make our sovereign identities more powerful, better than Web2 identities, so better than your Google account. So a Web2 identity in the Web2 world, the identity is stored in an account, let's say your Twitter account. You choose your username, your password, and they give you an account. Actually, they don't really give you the account. It's still theirs, but you can access it if they are willing to, and you start doing things on Twitter, you interact with others, and you are starting to build your identity. So here you have an identity in a Web2 account that is not yours. It's your identity. You have the same with Facebook, with Instagram, with LinkedIn. You have your identities that are on rented accounts. An interesting thing about these identities is that you still have some control over them. You can use them to connect to other services. That's the single sign-on. For instance, I can connect to Typefully with my Twitter account, and it allows me to, I can bring some part of my identity that is on Twitter to Typefully. So there is some sort of portability, but of course it's super restricted. At any point, if Twitter thinks that Typefully is competing with Twitter, they will remove the access of these accounts. So we see that, yeah, Web2 identities are not yours. It's super restricted what you can do with your identities. Of course, there's no possibility to link your identities together, meaning that it's impossible to create an event where you invite your Facebook friends, your Twitter friends, your LinkedIn friends, because they are actually competing on your accounts. Like, it's not your accounts, it's theirs, it's their asset, that's how they make money. They want you to put as much data on it as possible. And so that's not your identity. You cannot fully leverage it. And on the other side, we have the self-sovereign accounts that are, for instance, an Ethereum wallet. It's owned by a private key, meaning that the private key is the thing that you must have the private key to do anything with this account. What's amazing too is that it's permissionless. Anyone can create a self-sovereign account without asking permission to anyone. So, okay, that's great. What I can do with it, of course, I can start adding some Ether to it, for instance, and I can trade off Uniswap. It starts also to build my identity. Now I have some financial data on my account that is mine. I can buy an ENS name. I can buy an NFT, and I interact on social medias on-chain. So by doing this, a bit like on Twitter, I built my identity, but this time, this identity is mine. The data in it is mine, and it's controlled by my private key. By the way, by using ENS, I also create this as a public account almost. So very interesting. So that's one part. But actually, self-sovereign accounts are more interesting than blockchain. They are bigger than that. Because, okay, you can use the private key to send transactions, to use decentralized applications, but you also use them to log in into an app. I think you know, using Snapshot or other applications, that now you have login systems based on wallets. That's called sign-in with Ethereum. And you can log into an app, traditional app, but instead of an email and password, you log in with your wallet. So they also are wallets, self-sovereign identities accounts, are better than traditional accounts, even at Web2 stuff. So, okay, I can connect to Snapshot with my Ethereum wallet. I send a message. They say, okay, you're logged in. And what's great is that you bring your whole identity to the app. So what does Snapshot is, okay, you're logged in as Daedrian.eth, or you have some Aave, or you have some Uniswap tokens. You can vote on my governance with it. So that's where you can you start to see the sovereignty that we have over our identities with wallets, that I can bring my identity to the app. But there's something that is less cool, because it's the beginning, we're immature, is the fact that when I do this, I actually share everything, all my identity. Let's say that I have an account, my main account that is private with a lot of data, my ERC20s, my assets, my NFTs, so many things, and that I want to access an app to, let's say, that are gated by CryptoPunk owners because I just want to be part of a cool community and access a chat app. Using sign-in with Ethereum, I would have to connect with my main wallet and give so much data about myself. Here, what we saw is that at every time that I connect to an app with sign-in with Ethereum, I bring all my data. But again, the self-sovereign accounts are amazing. They're controlled by a private key, and you can do even more. You can do zero-knowledge proofs. And with this account, you can basically select a piece of data that you want to share, and that's it. So again, it's super powerful, and that's everything. That's what badges are about. It allows you to selectively reveal some part of your sovereign data. So again, what they are a tokenized attestation, meaning that when a wallet has this SBT, this non-transferable token, it means something about the identity. It's an attestation, like they have a CryptoPunk, they voted on the governance, they have a certain number of Twitter followers, stuff like that. It's ZK because it's minted by a ZK attester. This ZK attester is a smart contract that accepts zero-knowledge proofs, And OK, you brought me the knowledge proof that you have a CryptoPunk. Now I give you the badge that you have a CryptoPunk. And it's on EVM chains. It's deployed currently on Polygon, but we plan to go everywhere, especially on layer 2s, of course. Now, a small thing about badges, a small nuance that's not very important, but still, these are ERC 1155. Each badge has a token ID in this contract, and that means that each badge is a sort of ERC20. It's not really an NFT, it's an ERC20, and for the same badge, you can have different balances. So we'll see that later why it's interesting, but you have a value of the attestation corresponding to the balance of your badge, and the higher balance, maybe it means that you have more followers or your badge means more. We'll see that later. So the process of minting a ZK badge is pretty simple. I have a source account. Here is the Adrian.eth. I have data on it, my sovereign data. One piece of data is that I have a CryptoPunk. I want to prove it. I generate a ZK proof and send the ZK proof to the attester. The attester validates that. OK, the Adrian.eth has a punk. I validate, I'm in the badge, but the ZK attester at no point will know about my address. Last thing he does is that he stores nullifiers. We'll see that later. So to really understand better ZK badges, I like to use two identities. Let's say that I have my public wallet. Again, Adrian.eth, I have my ENS names, I donated on Gitcoin, I'm a verified human, meaning that I doxed myself. I uploaded a video with my name, my surname, and it's linked to my address. So this address is completely doxed, like everybody can know everything about it. I have some NFTs, I attended 2 conferences, so I have some POAPs. And actually, I have another wallet. This mine is my private wallet. That's where I do my degen stuff. I have a lot of transactions. I maybe have a lot of assets, hopefully. That's a dream. I don't have this, but that would be cool to be a degen. A lot of assets, a lot of NFTs, a lot of things. What's true is that I never want to connect them together. But I want to use them together because both have valuable data. And I want to use them together. So that's what our ZK badge is about. So the first thing that it allows you to do, I'm a verified human on Adrian.eth, I'm doxed. But now let's say that I want to access with my private wallet an application that requires you to prove that you are a human. Of course, I don't want to link them together. So what I'll do is that I will have the proof of humanity ZK badge on my unknown wallet, and it will just reveal what I need. That is, I'm a human. I have somewhere a source account that is doxed, and I was able to do this badge only once. OK. So now we'll get into the technicalities, how everything is done. The ZK attester I told you about, the one we currently use, is the Hydra S1 ZK attester. Hydra S1 is for the proving scheme, because this attester accepts a certain type of ZK proofs. And I'll explain what those ZK proofs are. So behind the Hydra S1 ZK attester, there's always a group of eligible accounts. That's how it works. So for instance, behind the proof of humanity ZK badge, there is the list of all the registrants that are on the POH registry. So of course, there is my address. We see that there is a value to each address, to each account. This value will be the balance of the badge. And with this, you can use it to code some sort of tiers. So let's say, imagine that in V2, POH have a super verified user. Like it's verified, but very well with KYC or I don't know what. You could have maybe the Adrian.eth with the value 2, and it will give the badge with the balance 2. And everyone that has 2 badges, like that has balance 2 of this badge, means they are super verified. So again, yes, here it's just you have POH, you are in the group with 1, you are not, you're not in the group. So you have the group of eligible accounts. These are the accounts that will be able to mint the badge. And we put them in a Merkle tree. It's a Poseidon Merkle tree so that it's snark friendly, we'll see that. But in the leaves, you have all the eligible accounts. We have the root, we publish the root on chain, and we'll see what we do with everything. So the way the badge is minted is first you go to your front end. So I'm on Sismo. I'm connected with the Adrian.eth, the source account. First, I upload the Merkle tree. Now I have in my front end, everything happens on the front end. That's what guarantees the privacy. So in my front end, I have the Merkle tree, I have my account, And what I will do 3 things. First, I will prove that I'm the owner of the Adrian.eth. And these 3 things will be done in a ZK circuit. So first thing, I'm the owner of the Adrian.eth. Second, the Adrian.eth is in the Merkle tree via Merkle proof. And the third thing is I actually own the destination account. That makes sure that I cannot give badges to others or that I cannot spam another account. So these 3 things, I'm the Adrian.eth, source account, destination account, I'm part of the tree. I do that in the ZK snark. I get a ZK proof. The ZK proof reveals nothing, but there is an address that, like, this user has proved to have an address that is part of the tree. I give that to the ZK attester, and the ZK attester does 2 things. First, it verifies the proof. OK, it's valid, ZK magic. And then it registers a nullifier. I think that there was some presentation at Devcon about this, but it's a way to make sure that from one source I can do only one batch. And for this, I register a nullifier. It's the anonymized version of my address, basically. So that's great. And now I have my badge on my destination account. And there's no leak. Nobody can know from this destination account what account was used to generate it. So again, we saw that this ZK attester allows you to prove from a group, to create from a group a ZK badge. And actually, this ZK attester, anyone here in the room can create its own ZK badge. That's what we build Sismo. We don't build Sismo to do some partnerships or stuff like that. It's a primitive. Everything is open source, of course. And very easily, in 15 minutes, if you are developers, we have a tutorial that helps you with that. You can fetch from your subgraph, from BigQuery, from anything. You can fetch your group, choose the metadata for your badge, choose the visual, and that's done. So again, anybody can create this ZK badge, can create the group ZK badge. And we just released today the factory of Sismo. It allows for even people that are neither coder or designers to build a ZK badge. It works that way. You add metadata. We have a SVG editor to create your ZK badge. And then you have just to copy-paste a list of address. You push the button, and done. You have your ZK badge available. So I think that's super great. So I invite you to try that. And before that, I'd like to, before getting, now I want to speak about the protocol. So we saw that Sismo is open. Anybody can add its group. It will have their own ZK badge for their user community. But even better, actually, so that's what I told you about. Anybody can add its group. You get the badge. Now what is even greater for more advanced developers is to create your own attester. Instead of using the rules of Hydra S1, I told you, verify membership, verify ownership, you can create your own new rules to verify the user request. So for instance, you can use semaphore. It's another ZK scheme that will be a ZK attester. But you can also use a public attester. Like the proof that you would require from user is not a ZK proof, but a Merkle proof and a signature, EC recover. Or you could even create a centralized attester, meaning that the proof you have to send to get your badge is a signature of the third party. So again, that's what we're trying to do. It's really primitive. We're not here to, we want you to have fun with this so that you can really control the data of your users and that you can build weird stuff like DeFi did in 2020. It did weird stuff with composability between all the financial applications. Here, what we want to do is weird stuff about the social capital that you have. So that's it. Again, all is open source. I invite you to read the docs and our GitHub. So now we get back a bit to recap a bit. So what it allows you to do, I told you that it allows you to import reputation from a public to an anon wallet, but you can do the reverse. Again, if I was a degen on my anon wallet, I could import this reputation to my public wallet, have an Ethereum power user ZK badge. It's a ZK badge that only top 0.1% Ethereum users can mint. And so that way I proved as the Adrian.eth that I'm a degen, but I never revealed my wallet. So that's, one big thing. The other thing, if you think about it, what happens if I mint the badge on a one-time address, fresh new address? What I've done by doing this is that I'm able to reveal just exactly what I need. It's not about building an identity. It's I need to prove to someone that I meet some criteria. I create a new address. I mint the badge there, and I'm able to prove exactly what I need. So here on Adrian.eth, again, I have a lot of data. One of the data that is mine, so Ren, is that I have the HCC POAP. And thanks to this, I can get, I'm eligible to the proof of attendance ZK badge. Behind this ZK badge, the group of eligible users is people that went to either a Devcon or HCC or ETH Berlin, very legit physical events. And so I'm able to mint that to a fresh new address, and then I can use this address to, for instance, get private merchandising or access airdrops to get into events. And with this, what I was able to do is prove that I went into one of the top conferences, that I'm a human, and not that I went to HCC, not I'm Daydream Notice. That's leveraging your data, that's what we call it. So super excited about this. The last thing that we intend to do that is not live is the way to aggregate your reputation. In Sismo, our governance is not token-based, or it is token-based, but not financial token-based. It's based on contributions, meaning that the more contributions you did for Sismo, the higher voting power you have. Again, it reuses the thing that I told you about, the balance of the token. Basically, the more contributions you did, the higher you will be in the tier of contributor and the higher voting power. So here, with ZK badges, you will be able to aggregate your reputation from your private wallet that maybe you held by using a lot Sismo, and from your public wallet that maybe you held by doing some threads, some communication about Sismo. So yeah, again, I think for governance power, this is very, very interesting to have reputation-based governance instead of just like who has been, like instead of ERC20s only that is financial capital, or communities that are ruled by an NFT that you just have to first come, first serve, and it's like airdrop farmers, this kind of stuff. Here, these tokens means a lot, and it's private, so you can really speak your mind. There's no risk at knowing that you're a team member or I don't know. So we are super excited about this new primitive. So now, I'd like to speak about the long-term vision of Sismo. Again, I'm able to aggregate I'm able to aggregate data. The way it works is that basically, anytime I want to use an account to prove some stuff about it, I will sign a message with it, and it gives this account the ability to be in the ZK world. Like from now on, I can prove everything about my data. So the way it works is that I will import into the Sismo vault. That's your encrypted data vault that is only accessible to yours. I will store the signatures that I told you about. So I sign with Daydream.is. Now I'm in the vault. With the anon, I'm in the vault. And now, as a user, I'm the only one that has access to all my data. And now it doesn't matter whether it comes from one address, two address, or I don't know what. I'm the user, I have access to everything, and I can use it as I want. So, for instance, let's say that I want to access an airdrop, and they require me to prove that I'm a human, that it's a CB-resistant airdrop. That would be great to have that. So they require me to prove and that I'm a human, and that, I don't know, that I traded a lot on their platforms, or that I am a big user. So that's what allows me the vault to do. I can generate the ZK proof, let's say on a one-time address, on the go, and I can connect with signing with Ethereum to this service and reveal just what I want. The other thing that is interesting is that you can, in the long run, we are using badges and SBTs because we think that they are tremendously great at standardizing things, because everybody knows how to fetch a token, how to read a token, and that's why I think that they have an advantage over VCs, actually, because the standardization is better, and you can do crypto-native stuff. What we did with ZK is the ability to programmatically code reputation in some sort. So we are very bullish on VCs and SBTs, but yeah, we are mainly using tokens. It's a big question. Why are we using tokens? Because they are great at standardizing. Once you have reputation as a token, it's super easy for anyone to fetch it, to know that. We have the sign-in with Ethereum tools and all these things. But on the long-term vision, do we really need to send the ZK proof to a smart contract to mint the badge if what we want to prove is to a third party? Let's say I want to prove to a merch store that I have CryptoPunk. Do I really need to send a badge on an address? Maybe not. I can directly send the ZK badge to this third party. So that's the big vision of Sismo, is really to be a Google Connect on top of your sovereign identities. You add all your accounts, your Twitter account, your GitHub account, your Solana address, your Bitcoin wallet, your Ethereum wallet. You aggregate all of that, and then when you want to sign to an app, they say, okay, I want, a bit like when you connect with Google Connect, they say, okay, they will access your email, your contacts, all these things. What we don't hear is that, okay, I connect with Sismo. This app wants to see your amount of, I don't know, NFTs, your total net worth, all these things. And you choose. You choose what you want. And if you choose to bring your full reputation, maybe you'll have access to the best services. But you can also choose to just reveal what you want because you don't want to give to this application everything. So yeah, that's really about Sismo is trying to. We have more and more on-chain data. We have more and more great projects that are bringing off-chain data to on-chain data. But today we cannot really leverage it. The privacy is a real issue about identity because we are used to Web 2 identity that are private because they are closed. It's closed gates. They don't want to share anything. So of course it's private by design. But on Web 3 it's public by design. But this also causes some issues. So I hope that I shared my excitement about what we can do with sovereign identities. And we're hiring, by the way. So if the mission is exciting to you, we are a very small team. We are just 7, but we are very passionate about what we do. So feel free to reach out. And again, everything is open source. We spent a lot of energy to the documentation, to the quality of our code. So yeah, we're here for the long term. We'd like to have many contributors, and yeah, reach out. Thank you, guys. Do we have time for questions, or I don't? Okay. So if you guys have questions, happy to.
Hi, thank you for the talk. That was super interesting. So my question was about updating of ZK badges. So for example, in the example you gave, you said you own the punk, and then you create a ZK badge that you own the punk. What happens to that badge when you transfer the punk and don't own it anymore?
Yeah. So actually, for the Hydra S1 attester, the badge is a snapshot, meaning that it doesn't update. But that's where actually the protocol is interesting, that you can create another attester that could be updatable, and like, I don't know, you could code that, like the way for a central party to update the root and make so that the badges that were issued are no longer issued. But I think that it's still a bit complex, and the best way is really to think about ZK badges as a snapshot attestation, and it's up to the application to ask for users to renew. So yeah, that's really the way we think about it now.
Yeah, hi. Thank you very much. Really cool stuff. Lack of privacy is, of course, one of the barriers in this ecosystem, so thank you for addressing that. I have a general question about how do you collaborate with individuals and projects within the space? Because at the end of the day, it's about going to market, and it's promoting your tool to individuals and teams that are building.
Could you explain what kind of projects? Any projects?
Yeah.
Okay.
Just more generally, what's your strategy to proliferate your tool?
Okay, so I think we are a project that should be used by many applications. First, I think that we are one of the first teams that are using ZK for a very concrete case. And as I told you about, we can have multiple ZK attesters. So if we have a ZK team that has created a new ZK scheme, we are using Gross 16, Hydra S1 that is very specific. But if another team has another way to create attestations, we can think about Chainlink's Deco, for instance. They are able to do ZK attestation from Web 2 data. They're welcome to build an attester here, and that's why we built it. For other teams, it's if you want to do reputation within your governance, you can create your ZK badge, or even better, you can create your own ZK attester and build logic in it. And so whenever somebody, let's say, mint a ZK badge that I played on a certain game, it updates the metadata of their NFT, or you can do so much things. It's really built to have fun as developers, but it's going to gain time for it to educate everybody. But generally happy to speak with everyone.
I have a question here. Really fascinating talk, super amazing. And one of the things that popped into my mind when you said that this is comparable to the DeFi movement, the DeFi summer, DeFi came with a lot of hacks and a lot of blood by fire. So how do you protect the privacy? Say we put all our addresses. have this like great identity, and how some of the risk of that, and what do you see for that?
Yeah, when I was saying that is that DeFi was raw. It was the first time we discovered, like before banks and insurance and all the financial services were provided by Web 2 applications that didn't talk together. And we discovered, what, I can deposit in a lending tool and then use that to bring liquidity to an exchange and then use that to stake somewhere. It's huge, but we could do the same with social capital. Like today, it's impossible to use let's say you are Uber driver, 2,000 drives, 5 stars. You cannot use it to get a good loan. That's what we want to do. Like, we want to have credit score based on reputation, and you can access a better interest rate. So again, we are a new primitive that should allow new stuff in a privacy-preserving way. So yeah, that's. I think it. Yeah.
I think that time's up for now. Okay. Maybe you'll be
really happy
outside
to stay there
for more questions. Okay.
Thank you.
Thank you very much.
Can I, please?
And now we are going to present our next speaker. He's going to talk about towards a future completely background compatible privacy layer for Ethereum. Y para los hispanohablantes, hacia una capa de privacidad con características completas y retrocompatibles para Ethereum.
Should I go up? Oh.
Please give a round of applause to Wei Dai. Welcome, Wei.
Yes. Thank you very much for the intro. So more privacy talks coming up. Of course, we're here to talk about privacy layers. In particular, what are privacy layers? Why do we need privacy layers? And how are we going to get a privacy layers that people need? So first, let me state the why for privacy layers. Obviously, the reason why we need privacy is because we don't have it right now. If you go into Etherscan, every single transaction is public, right? You're able to see the entire history of all the wallets. So the second reason why we need privacy is that if we want mainstream adoption of blockchain technologies, we really need privacy, right? It's one of the main hurdles, alongside scalability and identity and other issues. And finally, I would like to just quickly address on privacy and regulation issues. And there's effectively a spectrum of solutions, right, when you build privacy technology. Where on one side, you build fully self-sovereign solutions where only the individual control their information and assets. And on the other side, you could give a lot of control to the entity actually controlling this ecosystem, while preserving privacy between individuals. And so on the right side, you have something like CBDCs. On the left side, you have something like generative cash, right? And perhaps actually in the middle, we'll have something that's more or less maybe best of both worlds, where we could have a privacy-preserving system, yet give some limited form of control to some set of authorities. Okay, so enough on the why. Let's talk about what I mean by privacy layers. Just to reiterate, everything on Ethereum is public, so you're able to see everything on Etherscan. And first, what I want to define is the notion called anonymity. So anonymity is the inability to tell who is doing a transaction, right? So if somehow you're going to Etherscan and you look at a transaction and you can't really tell who the address, who's the initiating address, then we say that this system has anonymity. And second is the notion of confidentiality. If you go to Etherscan and you cannot see exactly what the trades are, then we say this system is confidential. And it turns out confidentiality is really, really hard on Ethereum. It's pretty much impossible unless you want to redesign the entirety of Ethereum, right? So on the other hand, anonymity is actually quite easy, right? We can use any mixer to mix the funds, and every single time we want to do an operation. However, this is very, very unusable, right? To the extent that only when you very much need this, would you do such a thing, right? Normal users would not do this for every single operation that would do on DeFi protocols. So the goal is really to make this very usable, right? How do we get usable anonymity for Ethereum? So, so what do I mean by, again, so just to reiterate, the system will have anonymity if you go to Etherscan and you cannot see who's initiating all these contract calls, right? So the question is, can we get something like this for Ethereum, right? And we don't want privacy anonymity just for payments. We want this type of anonymity for any type of smart contract call. So you can see, on Ethereum you can do many different things. It's an ecosystem of dApps, not just payments, not just peer-to-peer swapping of assets, not just NFTs. It's whatever you can imagine on top of token standards, right? We want to have anonymity by default for all dApps. So that's the question. And that's also what I mean by a privacy layer. A privacy layer for Ethereum should have the following set of features. But let us look at what are the current solutions for privacy layers. If you look at the entire ecosystem, we have many different EVM chains. That's more or less you can run a dApp and go to any of them. And we have many applications, sometimes on one popular chain, sometimes on many chains. And what are the privacy solutions? Well, we have some mixers, and we have some solutions that offer some type of DeFi compatibility. And we have solutions that more or less act as a layer 2 and with privacy. So for instance, Aztec and ZKPs are great examples of this. And on the other hand, we also have privacy alt ones. And the examples are like, for example, Alio and Manta, where it's a separate chain. It might be a different ecosystem, and you have to bootstrap all the liquidity. And so it turns out there's no single solution that works with all the dApps. So if you look at what these solutions do, so Railgun and ZKPs actually only do support some limited form of swaps. And projects like Aztec Connect allow actually pretty good DeFi interoperability, but it's not completely compatible with every single dApp, right? So for Aztec Connect, you need to write this custom bridge contract. And in fact, that's basically, if you go to every single Aztec hackathon, like that's what people do. They build bridge contract for every single dApp. And that's not scalable if you want this to support every single DeFi projects out there. So, this is observation. We don't have a privacy solution that is default and really usable, right? So, so let's look at what I mean by a privacy layer and what we should get in this privacy layer. So first of all, it should be feature complete. Okay. So what do I mean by that? You should have 2 features. You should be able to use this privacy layer exactly the same way you would use Ethereum, right? So you should be able to use a privacy preserving solution on any dApp that you want. And ideally, with basically the same interface, right? You go into a DI front end, you click some buttons, and you do a swap. And second, you should be able to disclose what you have done. Okay, so if you look at existing privacy solutions, it is actually really hard to tell someone else that you did something. The interface is not intuitive. Whereas right now, for the transparent solution, if you give someone your address, they know, they can see your entire history, right? So we want some type of form of information disclosure, right? So if you own a set of NFTs and you want to prove to your friends that, I own this set of NFTs and I authorize a message, you can do that. You should be able to do that really easily, right? Okay, and the second thing you should do is be backwards compatible, right? Because we'll have all this amazing ecosystem out there, all these apps that people use. We don't want to, throw that to waste and build something completely brand new. Right? We want to reuse the existing ecosystem. So the ecosystem should support ERC20, 721, 1155 standards, and it should more or less work with existing applications, right? And finally, most importantly, it should actually offer some form of privacy, which in this case, anonymity, right? So recall back to the previous slides, you will be the form, use this thing, and everybody will use this privacy layer, and you go on the Etherscan, no one can figure out who did what action, right? So the question for my talk is, can we build such a thing? And actually, the goal of my talk is to convince you that we could build such a privacy layer for Ethereum today, and we're building one. Okay. So let's look at how we're going to do this, right? So let's look at this, set of 3 things that we want for our privacy layer, and if you kind of categorize them, the first two features are basically what the smart contract wallet gives you, right? So if you're familiar with the kind of abstraction, where any type of smart contract wallet, this is the 2 things that this should offer you, right? You should be able to use it on any single application, and it's backwards compatible. And the second feature that's it's really what a mixer offers you, right? What a sharded pool gives you. So. So I realize, some of you might not know what a sharded pool or mixer is. So let me just reintroduce the two concepts. So first of all, what is sharded pool? A sharded pool allows you to unlink deposits and withdrawals, right? So this is the most basic form of privacy solution that we've had since the Bitcoin days, right? So it allows any user to deposit, and later on you should be able to withdraw. But by the time that you withdraw, nobody else should know who's actually withdrawing, right? So you withdraw to a fresh UA address. So that's the notion of a sharded pool, or mixer. And second, let's recall the notion of a sharded, actually, no, this should say contract wallet. Let's recall the notion of a contract wallet. What is a contract wallet? Well, for a contract wallet, the users actually do not own a EOA anymore, right? So for instance, for account abstraction, you will have different address that we use. But basically, for your smart contract wallet, you should be able to do the exact same things that you would do with your MetaMask, right? You should be able to submit arbitrary smart contract calls and get executed, right? And this is done in the form of an intermediary contract wallet that verifies some signature and carry out the calls for you. Okay, so that's the notion of a contract wallet. And recall what we wanted to do before. We said that the thing we want to build is basically a sharded pool plus a smart contract wallet. So here's what we're actually going to do. We're going to take the 2 and just put them together. Okay. So it's going to be a sharded contract wallet, right? So what can I do? You should be able to use anything that is on Ethereum, and every single time you use the wallet, nobody should actually know who's actually using the wallet, right? So there's one single sharded contract wallet that's shared by all the users in the ecosystem. Okay, so that's on a very high level, but how does this actually work? Right. So for sharded pools, like we said before, it supports deposits and withdrawals. And for contract wallets, you'll support arbitrary calls. And when we put them together, you will support, again, deposits and withdrawals, but also, crucially, something that you can use to call any DApp. All right. So here's the picture. Here's how it's going to work. It's going to be a smart contract sitting on Ethereum, where it allows any user to enter this ecosystem. And once they enter, they're able to use it as if it's a MetaMask wallet. And when different users submit transactions, they will they'll be reflected on chain. So if you want to call Uniswap, you want to call OpenSea, it should just work. And furthermore, on Etherscan, you have no idea who's actually behind the scene doing this operation, right? And as a bonus, actually, we can make this smart contract or contract wallet compatible with account abstraction, or EIP 4337. OK, so as it turns out, there's 2 problems, if you want to build this. If you want to build this, just combine a sharded pool with the smart contract wallet. The first problem is that when user submits a transaction that contains arbitrary calls, you can actually just steal the funds of the entire contract, right? So here, if the user only supposed to own 1 Ethereum in the pool, but it constructs a call that consumes 20 Ethereum, we shouldn't let this happen, right? Because people would be able to steal the entirety of the funds of the entire protocol. So what's the solution? Well, the solution for this problem is that we actually just separate out the two contracts into a contract that actually holds all the funds, what we call a vault contract, and a wallet contract, which will actually carry out the calls. So in this way, users will unwrap the tokens that they have, and only the tokens that they have is inside the wallet when they're executing a call. This is actually kind of equivalent to the other way of doing it, which is you also have a router and have the wallet holding all the funds and putting the things into the router. So there's kind of two equivalent solutions to solve the same problem. And the second problem that if you were to do this, which I think is the main reason why we don't have these things before, is that for this type of privacy-preserving sharded pools, you need to know the exact amount of tokens, what is called, that's encoded in a node, before you insert it into the protocol, right? So everything has to be known in advance. Whereas in DeFi protocols, you have no idea how much tokens you're getting back, right? So there's this uncertainty of the smart contract decides how much you get back. But traditionally for sharded pools, everything has been known in advance. And so this is like one feature that we didn't really know how to do before. And there's a solution for this, which is that we have this notion of refunding to an anonymous address. So we have to be able to read randomized addresses and refund to them. OK. So I realized I actually, basically sped through my entire deck and the end of the talk. So let's recap what have we learned in this talk. So first of all, privacy is really important. We do not have privacy on Ethereum. We need some type of privacy solution for Ethereum that's really usable before Ethereum can go mainstream. And a shielded contract wallet, combining a shielded pool and a contract wallet, is our best shot at this backwards compatible, feature complete privacy layer. And finally, we're building this out. We hope to put something in the public, and the hope is that long term for this ecosystem, most people will actually be inside a privacy layer instead of the standard UA layer. And if you're interested in contributing to this effort, please come talk to me. And I realized I didn't do a self-introduction at the beginning. My name is Wei Dai, a research partner at Bancapper Crypto. And come ask me if you have more questions about this project, and I'll take any questions from here. Thank you.
Congrats for the work. I think privacy is very important. I've worked for a few years on trying to make users have smart contract wallets by default. And the big problem is the gas cost of just having to onboard someone and already having to spend like $10, $5, sometimes $100. How do you think that can be solved?
Yeah, very good question. I think two things. One is the actual cost of gas over time as we build these scalability layers should go down, right, as we build more rollups. And the second is we could use batching to amortize the gas cost. So usually, actually in 4.7, there's a notion of bundlers and aggregators where you compress the authentication information from multiple transactions into a single authorization for all the transactions. And there's different tricks to kind of further optimize the gas cost. So over time, through these two avenues, the hope is that the additional cost incurred to get a contract wallet with privacy is not prohibitive for users, for vast majority of users.
Great talk. I'm interested a bit how you think about OFAC and Tornado Cash, because if this is like an opt-in.
Where's the question coming from?
Hi, over here.
Oh yeah.
Hi. No, how you think about, because if you look at Tornado Cash and the OFAC sanctions, how do you think about sort of avoiding that kind of thing with, because my understanding is that this would be like an opt-in smart contract wallet, so how can you avoid that and kind of adverse selection and these types of things?
Yeah, so referring back to my slides where I showed the spectrum solutions, I think as a builder, we should be flexible in kind of, so okay, what is privacy, right? Privacy is appropriate flow of information. I don't think privacy is an absolute notion where everything should be private to you. There's some societal consensus on what is appropriate flow of information, right? And everybody can have their own interpretation of that. Government agencies can have their own interpretation. Individuals in the Ethereum community can have, our interpretation, and they might be incompatible. But I think as builders, we should be open to different versions of what is appropriate flow of information, because technology is really flexible. And over time, there will be communities that might be incompatible, but we should work towards a solution that's more toward the center, I would say, where we include as many users into our ecosystem as possible, yet give some sort of control, perhaps, maybe, to some set of people to be able to prevent illicit activities.
So when you say we're building this already, how far have you got?
We have prototype contracts. It's very early stage. Yeah, so the idea has been there for a while, but the building is just picking up traction, and we'll have basically 2 people full-time on this.
But why not embed these innovations into an existing contract wallet, like Argent or something?
So there's many different contract wallets out there with different focus. This is a contract wallet with privacy. I think it doesn't make sense to. Well, I mean, we could take existing, we'll take the existing 4337, standard reference code base and just, fit this into there. The main difficulty is actually not being a contract wallet. It's really how to add privacy, I think, because we need to also change the front-end APIs. So, I mean, every single smart contract wallet have to do this, but I think for privacy it's more important because a lot of semantics need to change, right? So, if you think about how currently you pull balances, ready accounts, you first connect your wallet, you pull what is the connected wallet address, and you go to the contract and pull, okay, what is actually my balance? That cannot be made privacy preserving, right? Because you get who it is. So you have to change that into something like, connect to wallets, can I get the USDC balance? So a lot of things need to change when something needs to be, you want to imagine a privacy preserving system. So we'd love to collaborate with contract wallet projects. And that's also another reason why we're trying to stay compatible with 4337, because we can reuse, have the same bundler infrastructure and this account abstraction mempool. So we will be part of that ecosystem and contribute to that effort as well.
Great talk, thanks. What kind of zero knowledge protocol you decided to use?
Yeah, so as it turns out, the easiest way to prototype something like this is Circon still. There's nothing better out there that you can write a zero knowledge circuit and have Solidity verifier and a prover that's running in a browser. Circon is the only ecosystem. So this is another rant. I would use the most efficient proof system out there. It probably more Plunk, but that tooling's not there. And also over time, it sounds like you're familiar with this type of systems, but over time, there will be kind of 2 separate proof systems, right? So one is on the user side, where you essentially want zero knowledge property only for privacy. So what is this thing? The overall design is very similar to any other shielded pool. You have a Merkle tree of nodes, right? You're referring to a node and spinning it without revealing which node you're referring to, right? And for that you need zero knowledge to preserve your privacy. And you actually don't really need succinctness. And we're going to have this aggregation layer that roll up these user spinning proofs. And for that, you really want succinctness, right? You want to be able to verify on the contract side really efficiently, right? And so, I think this is something that has been discussed a lot in Devcon in the past couple of days, which is you have the notion of an inner proof and outer proof, right? So for us, this inner proof will basically be the user proofs that have zero knowledge, right? We can use, I think over time, will probably evaluate things that's really fast in the browser, adds to your knowledge, and maybe some type of compression, so like maybe Spartan or something. And then on the outer proof, we'll have, probably Gross-16 or Planck that really compresses all the other proofs, right? Yeah.
So one approach to solving this problem would be to make backwards compatible contracts on Ethereum. Other approaches might be to wait until there's an L2 that has more primitives built in that support this. And I'm just curious to learn more about your thinking of if it ever makes sense that privacy will be in one place and non-private things can exist in another.
I think, yeah, so yeah, the question is, do we build privacy solutions on top of existing things, or do we build a new ecosystem to build privacy-preserving solutions? And I think the key question is, what are the privacy supported, and what is the features of those applications? And so it turns out that the short answer is there's no privacy-preserving ecosystem right now out there that actually support more features than anonymity. Okay, so if you look at like Alio or like Mina, it's really just a solution to build rollups. Like, with zero knowledge, you cannot get privacy for shared states. So I actually discussed this in another talk of mine. So if you think about the features we can support, I think unless you have vastly more capabilities to support privacy-preserving solutions, which I think is actually privacy of shared states, it doesn't make sense to have a complete brand new ecosystem because the privacy that's achievable is the same. So there's no benefit to building a new ecosystem that do the same thing, right? So therefore, so if that's the case, we should build on top of existing ecosystems because everyone's there with desperately need privacy solutions, and it's possible to build it. So, let's not reinvent the wheel.
Is it working? Yep. So it sounds like you need a sequencer for maintaining the Merkle tree. Have you got thoughts on how you're going to decentralize that, or whether you will?
Yeah. So there's actually kind of two different things, right? So for 4337, you have the notion of bundlers. And we could basically use that. So we could actually, so bundlers, so I think it's yet to be determined exactly what's in the standards, but it seems that for every single contract wallet, bundler needs to run custom code to be able to compress different user operations to one. So we could essentially stay compatible to that standards when it's more finalized to be able, to have essentially to plug into that ecosystem, right? So there could be like different 437 bundlers that's supporting different smart contract wallets, and we'll be one of them. And in that way, we can decentralize bundling. And the second is, yeah, so exactly, so there might be this management of Merkle trees that's separate to compressing multiple user operation proofs into one. And we can make that permissionless, yeah, I think is the current thinking, right? So, okay, what is the overall story? Is that, so because we're backwards compatible, right? We support the exact same set of operations. Users need to pay more gas, right? It's like you're paying the same amount of gas by default. And the additional things, that's the overhead to maintain everything. And the idea is to make it as small as possible. And the only way to do that is to outsource this aggregated work into some sequencer or bundler. So it's basically necessary if you want to make this user usable. And so yeah, so to decentralize, I think make it permissionless and really design incentives around this, right? That's because these are bundlers, sequencer are providing a service. We should incentivize behavior and make it permissionless and design kind of this ecosystem that's self-sustainable, right? Because I think users will pay for privacy if it's cheap enough, and you can get this network effect, right?
Thank you so much, Wei. That was fantastic. And now we are going to present our next speaker, He's going to talk about ZKPs and Programmable Cryptography. Y en español, ZKPs y criptografía programable. Gapshit is the creator of Dark Forest and runs applied ZK research and development at 0x Park. Please give me a round of applause. Keep shot. Welcome.
All right, start. Cool. Hey everyone, I'm Gubsheep and I work with a research-focused organization called 0x Park. Today I will be talking about this idea of ZKPs and programmable cryptography, which is a phrase that we use to describe a lot of what we focus on at 0x Park. I'll describe what programmable cryptography means and why we think it's important for anyone who is interested in the future of next-generation blockchain and decentralized applications. So first off, I'll give a little bit of context into what 0x Park is for folks who have not heard about this organization. 0x Park is a relatively new research-focused org which supports what we call application-level R&D on Ethereum and other decentralized platforms. So this means trying to better understand what is possible to do on these kinds of smart contract platforms or with new decentralized application technologies that isn't necessarily currently possible today, but might be on the horizon. Projects that we support include things like Dark Forest, as well as Personae Labs, building things like HeyAnon, or if folks were around the Applied ZK showcase yesterday, you might have seen proof of email or various ZK machine learning experiments. We also build circuit primitives for ZK snarks and focus a lot on infrastructure maintenance and third-party development of tool stacks like Snark.js, Circom, Halo2, and more. And we also do a lot of community building efforts, and we work on cross-team and ecosystem-wide projects as well. Cool, so one of our largest areas of focus at 0x Park is applied ZK cryptography, which means that a big focus for us is understanding what is possible to do with ZK crypto, what theoretically should be possible to do with ZK crypto and decentralized apps, and what we need to do to get there, to eventually bring those kinds of tools to production. And applied ZK is one of a category of relatively newer cryptographic primitives that we categorize under this term programmable cryptography. In order to describe or give a feeling for why programmable cryptography is important, first I want to go into a little bit about a couple of the reasons that we think that applied ZK is especially important. So there's two concrete reasons that I think are especially compelling in terms of why ZK is going to be powerful for unlocking the next generation of decentralized applications. I'll just go through those real quick. So the first thing is that zero-knowledge cryptography gives us what I think of as an expressive language for claims. So what does that mean? We'll go through an example to get a sense for what an expressive language for claims looks like. Let's take the example of ZK snarks and group membership proofs in the context of claims about digital identity. So the simplest kind of identity claim that we have from cryptography, and something that we've known how to do for many decades, is prove a statement like, I know a private key corresponding to someone, say, like Alice's public key, which implicitly identifies me as Alice. So this is something that I can do with a digital signature, something like RSA or ECDSA. The invention of public key cryptography made proofs like this possible, or made provable statements like this possible. And this is infrastructure that underlies so many of the digital systems that we know and rely on today, including secure traffic on the internet, as well as blockchain systems like Ethereum or Bitcoin. So going up one level in complexity from the previous slide, we have claims like, I know a private key corresponding to one of the public keys in a group. So for example, I know a private key corresponding to one of Alice, Bob, or Charlie's public keys. This kind of claim is commonly referred to in the literature as a group signature or a ring signature. We do have cryptographic protocols that are purpose-built to enable people to generate group signatures or ring signatures, but they are, again, special purpose-built for this kind of claim. And the math, or like the cryptographic protocols that make these sorts of claims possible, are oftentimes incompatible with the math used for ordinary signature schemes. So we figured out how to do these group signature schemes a few years after we figured out how to do digital signatures in general. However, it is the case that in order to make claims like these, or in order to build up a system or a network in which people can make these claims, you have to bootstrap like an entirely new key registry. You have to build a different key generation algorithm, and you have to popularize that. So, the math involved in making a claim like this can be incompatible and require you to sort of move to an entirely different system than if you want to, use systems that allow you to make claims like this. So one thing that I want to note is that today, however, we have another much easier way of enabling these kinds of claims, and a way which is actually compatible with systems for proving the first kind of claim. So with ZK snarks, the problem of building a system that allows you to make these kinds of claims from a system that allows you to make these kinds of claims is actually a really simple, essentially two-line code change in a ZK circuit. So rather than having to invent an entirely new mathematical protocol or new key generation algorithm, if I have a primitive that allows me to prove in a ZK circuit that I possess a public key corresponding to some private secret, then what I can do is I can construct a ZK circuit that says, I know some public key corresponding to some secret private key. I'm going to keep that public key secret, and that public key minus #1 times public key minus #2 times that public key minus #3 equals 0. So if I can prove all of this in zero knowledge, what I'm effectively proving is that I know a private key corresponding to one of these three public commitments, #1, #2, or #3. So this way, I now have this system which uses the exact same key generation algorithm or key generation strategy as a system that allows me to simply prove that I know the private key corresponding to Alice's public key. And we've turned essentially this problem of building group signatures from a math problem where we have to go to a cryptographer, they have to write us a paper, I'll do all this stuff, bootstrap a new key registry, into essentially a programming task that any developer familiar with, say, CIRCOM can carry out. Okay, so slightly more complicated than this, we can go a level even further up and consider augmentations to this protocol, such as I know a private key corresponding to one of Alice, Bob, or Charlie's public keys, and the other two either can or cannot prove that they did not generate this message. So sometimes this property is called by various different names. Some call it like disavowal. So as an example, like suppose I'm Bob and I generate a signature that is either coming from, you can see is coming from one of Alice, Bob, or Charlie. Alice or Charlie might be able to generate a proof that they did not create that signature. So yeah, there's cryptographic systems that allow you to toggle this property on or off. But again, these use new math, are incompatible with previous systems, and are generally fairly difficult to engineer. Again, however, with ZK snarks, this is a pretty trivial, like, two-line circuit code change. So again, we're sort of seeing this idea of this language that allows us to build these expressive claims that are compatible with previous claims that other cryptographic systems will allow us to generate. And finally, we can get to claims of this level of complexity, something like, I know a private key corresponding to one of Alice, Bob, or Charlie's public keys, and I either possess a signed attestation from one of David, Eve, or Fred, one of these trusted attestation service providers, or during a block with header X, I knew the private key corresponding to an account with at least 32 ETH, and you can kind of compose a bunch of arbitrary predicates on this identity claim. And I think it's pretty fair to say that there's like no cryptographer in the world who you could go to and ask them to build a special purpose new cryptographic tool that would allow you to prove this specific kind of claim, nor would it even make sense to. But again, with ZK snarks, this actually becomes fairly trivial. You have your building blocks in ZK circuits for each of these things, key pre-image, signature, recovery, proof of inclusion in the Ethereum Merkle-Patricia trie, and then you can just put all these together, essentially calling all these like different functions in your ZK circuit code to start building out these claims. So another framing of this idea of the expressive language for claims is that ZK snarks turn math problems into programming tasks. Rather than having to go to a cryptographer to write you a new paper every single time you want a new kind of digital identity claim to exist in the world and be provable, you can just have a ZK circuit developer compose the right primitives inside ZK circuit code. Okay, so cool thing number 2, which is closely related to cool thing number 1, is that ZK adds interoperability to cryptographic systems. So what does this mean? Well, to explain this, first I just want to do a quick breakdown between two terms, snark-friendly versus snark-compatible cryptographic primitives. Snark-friendly cryptographic primitives are primitives like hashing algorithms or digital signature schemes or encryption algorithms that are specifically purpose-built for to be efficiently provable inside of ZK snark proving systems. So for example, the MIMC or Poseidon hash functions or EDDSA signatures. These cryptographic primitives oftentimes have been invented in the last couple of years, and the hope is that with these primitives we can move towards a world where we can do more and more inside of snarks. However, most of the cryptographic systems that exist in the world use cryptography that was invented before we knew about ZK snarks. So for example, a lot of hash functions use a lot of bitwise operations, which are very costly to do inside of ZK snarks. And so these systems are not snark-friendly, but they are what we have to work with. So for example, all the signatures on emails signed by mail servers that are being sent out are not going to be snark-friendly signatures. However, we can start to at least connect all of these different snark-compatible systems together by embedding these different signature algorithms, hash functions, encryption schemes, et cetera, inside of snarks, even if it is costly. So as an example of a few crypto systems that exist out in the wild, we've got key distribution and identity registries, such as you can build an identity registry of GPG keys. GitHub allows you to generate locally a key pair and upload it and make it publicly accessible to anyone so that anyone can verify your commit history or things like that, repos you've contributed to. So for example, if you go to github.com/gubsheep.keys, you'll see my RSA keys. Ethereum and Bitcoin rely on the ECDSA signature scheme. So addresses are going to be a hash of an ECDSA public key in Ethereum. And I think mail servers use the DKIM protocol to sign and authenticate messages, which under the hood relies on RSA. So one of the things that's going on with all these different signature schemes is that they kind of can't really talk to each other. If you're running on the RSA protocol, you can't really understand an ECDSA signature. However, by making all of these primitives snark compatible, by implementing RSA signature verification, ECDSA signature verification, et cetera, inside of snarks, what we can start to do is we can start to build adapters between all these different systems. So again, if I have an RSA primitive and an ECDSA primitive inside of a snark, then I can start to make claims like either I have a GitHub account that's contributed to the Ethereum GitHub org, or I possess at least 100 ETH. And again, by making existing cryptography snark compatible and combining that with this expressive language for claims, we can start to make statements about all sorts of digital or online activity. So both of these features are examples of the power of programmable cryptography, which probably as you've grokked from now, both of these features are giving us these tools to much more flexibly manipulate digital objects. So now I'm going to kind of give my description of programmable cryptography, which is that it is cryptography that can be layered on top of arbitrary computations. To contrast this with cryptography that we've been using for the last couple of decades, well, for most of cryptography's short history, the set of mechanisms that we've been able to instantiate with our tools has been quite narrow. So we can say things like this message originated with Alice, as we've seen, or this message can only be read by Bob. But every single new mechanism that we want to build, whether it's like arbitrary identity predicates or read permissions or things like that, would require us to build a new special purpose cryptographic system. However, now we're seeing tools like ZK snarks, as we've discussed, that allow us to move from this message originated from Alice to I know a private key corresponding to one of these people, I have an attestation from one of these service providers, et cetera, et cetera. To things like witness encryption. Witness encryption is a primitive that essentially allows you to encrypt data not with like a key pair, where someone has to know a certain secret to decrypt the message, but it allows you to decrypt messages with, encrypt messages with a program. So for example, I can encrypt a message with a Sudoku puzzle, and anyone who solves the Sudoku puzzle will be able to generate a key to decrypt the message that I've encrypted with witness encryption. And this allows us to move from systems where we can do things like Charlie has published some secret vote that only a coordinator can read with the coordinator's private key, to Charlie has committed to some secret vote that only attesters with a certain permission level can decrypt today, but which a class of auditors with a lower permission level can at least partially decrypt in exactly 1 week. I would say that smart contracts also spiritually kind of fall in the same category as a lot of these other programmable cryptography primitives. So, imagine very early on in the history of this idea of blockchains, we would have these consensus engines where people could come to consensus on only very simple or specific data transformations. Data transformations like, Bob can decrement his balance by 100 ether to increment Alice's balance by 100 ether. Nowadays, with smart contracts and programmable blockchains, we can sort of execute arbitrary predicates. At block B, 100 ether will be available for withdrawal by Bob, so long as Bob has closed his position in some smart contract and no one's submitted a fraud challenge, though an early withdrawal may be initiated if 2 of the following 3 solvency conditions are met, et cetera, et cetera. So in each of these examples, there's this common theme of moving from the specific to the general. With ZK snarks, I can move from proofs of specific claims to a general purpose language of claims. Smart contracts allow us to move from coming to consensus on canonical data that can be modified in only very specific or narrow ways to a general purpose language for modifying or executing code on this canonical data. Witness encryption moves us from a world where we can permission data to only be read by a specific person or a specific set of people to having a language for specifying arbitrary predicates for read permissions. So I kind of imagine this as like, decentralized OAuth tokens where anyone can plug into this like global authentication system and specify who can read what and when. And there's all these new primitives that are continually getting better and better, and more feasible, things like fully homomorphic encryption, multi-party computation, even really far out things like indistinguishability, obfuscation, and more. There's a couple of folks who have sort of independently come up with this categorization or framework. I believe the Cersei team calls these computational crypto systems, so very similar in general spirit to what we're calling programmable cryptography. Okay, so the second part of this basically thesis is that programmable cryptography itself seems like a very powerful tool. Blockchains are also a very powerful tool, but it's not sort of a priori obvious like why these two things are related to each other, except that they both sort of derive from similar mathematical principles. But I claim that there's actually a very deep and complementary marriage between these two powerful things. And to explain why I think that is, first I want to give my kind of mental image of what Ethereum as a data availability layer looks like, say like 5 or 10 years out from now. So in my head, the way that I kind of conceptualize the idea of Ethereum, the global data availability layer, is I think of Ethereum almost as this like giant, super thick coaxial cable that basically streams humanity's like global stream of consciousness. So humanity's promises, bets, secrets, debts, dreams, et cetera, et cetera. And this coaxial cable is made available to any person or computing device in the world. So any phone, any computer that lives on some institutional server, anything like that, can hook into the 1 gigabyte per second canonical data stream, look up data, and know that they're seeing exactly the same thing as someone across the world is seeing. Now, right now, this data stream is completely transparent. And that has been a design decision that has been necessary in order to gain acceptance of this particular data stream that we're wanting to claim is the canonical data stream, or the legitimate data stream. So in order to build acceptance, we have this principle of don't trust, verify, and in order to verify, you need to be able to see all of the data. But I claim that this is actually extremely limiting. There is a wide class of applications that you might care about to build where you don't want every piece of data to be completely public. And I think that when a lot of people talk about this idea of privacy or information asymmetry, people have various different beliefs on various ideological nuances around privacy. But I want to go even a level lower to explain why I think this is important. Privacy is important not just as a matter of ideology, but simply as a matter of mechanics. There's certain coordination systems that just don't work unless you have information asymmetry. And in fact, most of the complex systems that we see in the world today, and most of the organizations we have in the world, rely on the idea that different people know different stuff and can do different stuff. So the way that I think about this is that what we would really like to do is we'd like to be able to enforce read, write, execute permissions on this canonical data stream that is the blockchain. And the way that we do this is, in fact, programmable cryptography. Programmable cryptography gives us these expressive tools and languages for enforcing read permissions, like we mentioned with things like witness encryption, or write or execute permissions, which we're seeing with things like, ZK snarks, and smart contracts, and more. So to give just a toy example of why this kinds of permissioning or access control is really important, I want to consider the example of games. So, for example, let's consider poker. In poker, a lot of the depth of the game relies on the fact that I know my cards, but I don't know your cards, and you know your cards, but you don't know my cards. Poker as a game would simply not work if we knew each other's cards. It would be completely degenerate, right? It wouldn't really make sense. It wouldn't be any fun. A slightly more complex example of this might be strategy games. So a couple of days ago, we had a talk on Dark Forest, which is a fully on-chain strategy game. You can kind of imagine it as something like StarCraft on the blockchain. And one really key mechanic of Dark Forest is that in Dark Forest, players' respective locations are all hidden, which gives the game a lot of its relative strategic depth. So the general pattern here with games is that oftentimes what we're going to do is we're going to have players commit to a state that they keep private, and whenever they want to make a state transition, they're going to provide a zero-knowledge proof that they are making a valid update on their private state and committing a valid state commitment to the network. So this proof might prove something like, I'm moving my secret knight from secret location A to secret location B. I'm not going to tell you what A or B are, but this zero-knowledge proof proves that there's an L shape between them. Or a zero-knowledge proof might prove something like, I'm drawing some card, I'm drawing it validly according to the rules, I'm drawing it out of a randomly shuffled deck, I'm not cheating and just continually drawing a bunch of aces. So, there's a bunch of game examples which we can kind of imagine where the game just simply does not work if all of the information is transparent. And while those are kind of toy examples, I think they allow us to start to hint at this more complex future where we're using blockchains for a much wider range of use cases. So, I think one completely reasonable digital interaction we might expect to see something like in the future is, imagine I walk into a store and perform a cryptographic handshake with the merchant and perform a multi-party computation with some identity provider. After verifying the merchant's identity, I give the merchant one token that permissions them to access some specific data on my preferences for an hour, and another token that allows them to transfer a limited amount from my balance. After that transaction completes, I update my transaction history that's private to me and committed on-chain, but only visible to myself. So, each of the components of this interaction today are not possible due to the fact that there's so many constraints on what we can keep private. But again, with things like fully homomorphic encryption, witness encryption, ZK snarks, et cetera, these kinds of interactions may start to be unlocked while still preserving the neutrality, where all of this data is living on some like globally verifiable blockchain or data availability system. So the last kind of like analogy that I want to make here to kind of create an image of what this future might look like is, I want to kind of describe the concept of an ender chest from the game Minecraft. So Minecraft is a sandbox game in which you can harvest resources and build stuff. And in Minecraft, there's this concept of chests. So with a wooden chest, if I build a wooden chest, I can like place it down here. I can put items into the chest. If I leave and come back, the items are still going to be there. The chest is a very important like primitive in Minecraft. If anyone else goes to the chest and they open it, they're going to be able to see all the items that I've placed in there. In Minecraft, there's also a very powerful tool called the ender chest, which is sort of similar to a chest but has this kind of magical property, where ender chests inventories are marked as like per player inventories and are sort of shared across every ender chest that exists in the world. So if I put an ender chest down here and put down like, 5 stone or something, and then I put an ender chest down over there, and like I walk over there and open it, I'm going to see that same 5 stone. And if someone else walks over to the ender chest, they're not going to see that same inventory that I have. They're only going to see what they've put into the ender chest. The ender chest is an incredibly powerful tool for Minecraft players that allows them to execute on these larger scale strategies, build these much more complex constructions. It just makes it easier for you to do a lot of things. And I think as more of our social and economic activities move online, we're going to need primitives like these digital ender chests that allow us to carry things like our reputation, our financial history, our social context across different platforms. And in order to do that, we're going to need these new privacy-preserving mechanisms that fall under this category of programmable cryptography. So that's all I've got for today. If you're interested in any of the work that we're currently working on around programmable cryptography or anything else, you can check us out at zeroxpark.org, or you can find us on Twitter at zeroxpark. But thank you.
Hey, thank you for the talk. As we went through a lot of the slides, there were examples of ZK things where you have a claim and it's true or false and you prove it. But I guess the bigger picture of all programmable cryptography could have other sorts of statements like, I summed all these numbers and this is the true sum. And so I guess those are other flavors, and maybe that's homomorphic encryption, I'm not sure. How friendly are those with each other right now? Like proving things and doing math and getting continuous results?
Yeah, this is a great question. So right now, as you've probably noticed, like we are specifically very focused on zero-knowledge cryptography, which is, one piece of this like much broader category, but it seems like disproportionately represented. So why is that the case? Well, one reason is that zero-knowledge crypto systems are simply much more mature today than a lot of these other systems where there only exist theoretical constructions or academic implementations. We expect things like witness encryption, for example, to be much further out, and we're still even trying to like describe the landscape of what is possible to do with multi-party computation. So unfortunately, none of these systems are super compatible because a lot of them don't yet like exist in a form where you can meaningfully start playing around with them. But we hope that that is going to be evolving rapidly over the next, say, like couple of years.
Hello. Thank you very much by your talk. Have you made any kind of research around quantum cryptography, ZK?
Yeah, so I think quantum cryptography is a slightly like orthogonal direction to what a lot of these tools are going to enable. Specifically, for example, like one way that we think about the interaction of quantum cryptography with these tools is considering which of these tools or like which, for example, ZK algorithms or like FHE algorithms we have are quantum resistant. In other words, once we have quantum computers, which of these algorithms might we be able to break? Now, that's kind of a different thing, however, from necessarily the affordances of these tools. So, for example, like when I think about programmable cryptography, I usually think about it from the perspective of like what these things can do for us, rather than necessarily like what's the underlying algorithms and what are the computational models in which they might broken by or enabled by, whether that's quantum or elliptic curves or large prime fields or things like that.
Thank you for the talk. Can I ask you, if I understand it correctly, the state currently in Dark Forest, you keep it locally and you just put the proofs on chain. That may not be ideal for the future. If you lose the state, you kind of lose the game. What are your thoughts on how to keep the state safe in other ways, either using a homomorphic encryption, or your general thoughts around it?
Yeah, this is a great question, and I think as an extension of the debate that people have around the viability of everyone custodying their own keys, for example, on a blockchain. I think that there are a couple of things here that might be possible. One is, like you mentioned, fully homomorphic encryption might allow us to store private state on that is encrypted on cloud services, but still be able to retrieve that data and perform operations on it just like we would if it was local, while still preserving the privacy of that data. That's pretty far out, though, and in the meantime, I think the most immediate thing that we can focus on doing is building more user-friendly solutions that allow you to keep critical or sensitive data on your own machine. I mean, everybody already does keep critical and sensitive data, so it's a question of as the volume of that data or as the sensitivity of that data grows, then how can we make those systems even more and more ergonomic and more secure?
Hi, thanks for the talk. What do you think about the fundamental bottleneck of ZKPs being quite slow, and you have this trade-off between proof generation and verification? Do you think we will have sort of more external off-ramp solutions, maybe layer 2s for ZK, or do you see the most promising solutions being in fundamental ZKP research? What do you think of that whole performance trade-off?
Yeah, so personally, I think that there's still a ton of low-hanging fruit in terms of performance optimization for these currently very expensive crypto systems. For example, with ZK, by some metrics over the last 3 years, over the last 4 years, the size of circuit, or the size of computation that you can ZK prove in browser efficiently has expanded by 3 orders of magnitude. And we're still seeing rapid improvements via new protocols, new, better engineered libraries for proving stacks, more efficient circuit implementations, and things like ZK-friendly hardware are just getting started. So I think that while eventually there may be some industry of services that arises around offloading computation or things like that, at the moment there are still a lot of optimizations that have not yet been fully explored that I think can enable some really, really complex proofs even on small client devices like mobile phones.
Is there any other questions?
Cool. Thank you.
So for now, we are going to have a 1-hour break, and we are very excited to meet you again in this stage at 1 o'clock with our next speaker, Juan David Perez, with the Ethereum event showcase. Please enjoy your break and see you at 1. Thank you very much, and see you then.
Yesterday. So good afternoon, everybody. Hope you enjoyed your lunch. I'm going to be your MC for this afternoon. My name is Joseph. And it's my pleasant duty to introduce Juan David, the community supporter in the Ethereum space. He's going to introduce more Ethereum community events.
Yeah, there's going to be some sort of like a panel. So we have with some event organizers, we just like have a group where a lot of amazing and talented organizers have been doing great stuff. So we're going to have 2 minutes per presenter. And they are going to tell us why they created this, an invitation to join, and basically that's it. So first, I don't see Carol. Carol, where are you, Carol? Carol, ¿dónde estás? Carol is not coming, but we're going to start maybe with Eleanor from ETH Dam. This is just alphabetical order, first Brazil, then ETH Dam. Come on, to the stage, Errol. Big round of applause.
Thank you. Hi, everyone. My name is Eleanor Blank. I'm a crypto educator first and the founder of Crypto Canal. And this year I had the honor of organizing ETH Day and DeFi Day during DevConnect. And it just makes absolute sense for me to just keep the flame alive and burning in Amsterdam and to create a conference hackathon dedicated to privacy. We have a situation right now in the Netherlands with Alex of Tornado Cash being in jail, and I want to dedicate this event in the spirit of the cypherpunk movement and make this a very special event for the Amsterdam community. As mentioned by Tim Beko on the first day, we need to now integrate these developers that have a difficulty attending conferences. So I would like to extend the invitation to all core devs who have worked on the merge to join me in Amsterdam, May 2023 for ETHDAM. Thank you.
Thank you so much. Please. Now we have Carol from Brazil. She's going to speak in Portuguese, so let's try to do some live translation.
Buenos dias.
Good morning, GM.
Sou Carol, representante da Ethereum Brasil. A Ethereum Brasil, ela começou no Ethereum Rio. Foi um evento de muito sucesso no Rio de Janeiro. Na verdade, foi um marco muito importante para a comunidade brasileira.
Okay, so she's Carol. Even for me, it's hard because I speak Spanish, but we can understand a bit Portuguese. So she has been leading this first Ethereum Rio, and now they're thinking country-wise.
E após o Ethereum Rio, percebemos que precisamos consolidar a comunidade Ethereum no Brasil.
After Rio, they want to grow the community in Brazil.
Depois de Ethereum Rio, tivemos Ethereum São Paulo, que foi focado na construção da comunidade.
After Rio came São Paulo, and is to keep building the community.
Quais são os próximos passos do Ethereum Brasil? Iremos descentralizar, temos uma estratégia de descentralização, no qual vamos criar collabs do Ethereum Brasil.
Next steps is to decentralize Ethereum Brazil and create collabs between different groups.
Juntamente com estados, cidades e universidades.
With different states, cities, and universities.
Exatamente porque o Brasil é muito grande e precisamos construir dentro dos territórios.
Brazil is huge, and they need to go local to the grassroots communities.
E temos como objetivo também fazer o Etour, que seria um dia educacional na verdade, em 6 estados no Brasil.
They want to do a tour, so they're going to move to different 6 states, and they're going to be doing some education days.
Sim, e teremos a Ethereum Rio em 2023, que será focado não só na comunidade internacional, mas principalmente no Brasil.
So they have Ethereum Rio in March. I think we want to go to Rio, one of the most beautiful cities. So thank you so much, Carol.
Obrigada. Thanks.
Next, we have East Denver.
Thanks, guys. We are super excited to be here. DevCon's been an amazing week, and it's just such a pleasure for us to see more community of communities, because ETH Denver's been around since 2018. We're one of the longest running events in the space, and we are super excited to come back for another year. For those of you who joined us last year, we had a couple of hiccups. It was a little bit trickier than normal. We grew from about 2,500 to about 12,000 this year, which was pretty crazy for us. Thank you all for those who had to wait in line, who dealt with some of the restroom situations. But this year, we're super excited. We've got a new venue. We're all going to fit under one big canvas. We're going to be on site together. And I'm dumber than the clicker. Thank you. So again, big activations, we're going to have 200 cots on site this year, so we're going to have more emphasis on scholarships. Obviously, the event is going to be free, as it always is, so people can just come, attend. The focus is on really contributing to Web3. We want to make sure that we're adding, that we're building. So we onboard newbies. It's free for everyone to attend. We feed everybody 3 meals a day. We've got bodegas like they have here and big activations. Again, please tell your friends who need scholarships and support. We're really excited to bring people together and focus on the Biddle-a-thon, which is going to be longer and more in person this year. But please come and join us, network, create. We're so excited to see you back again.
Thank you so much, Shannon. Now we have ETH Gathering. Tadeo is coming.
Hello?
Perfect.
Okay, I think I can do the green one. Hey everyone, nice to see you all. Thank you. Here to present ETH Gathering, Barcelona 2022. There we go. Okay, so it's actually next month, so it's very soon. We basically want to do something specifically for Web3 teams. I think I've been working at Maker for about a year, and the biggest benefit that we get from here is actually getting all together, meeting each other and collaborating in person. So we kind of want to craft that experience. We have in let's say, two sides of it. One is the gathering week. We invite everyone to come, work from lovely Barcelona, and collaborate with other teams. And then in the conference weekend, we're going to be doing panel discussions, workshops, and working sessions, apart from having some technical talks. Let me talk about working sessions. These are private meetings that you can have with people across the industry. You close the door and you really talk about what's really important. Because I think we all have the same issues, we're all trying to solve the same challenges. Yeah, we actually have the main themes, which are DeFi, security, DAOs, and data. But we also have other subtopics such as staking and wallet, UX, and security. So very welcome to everyone. And please join us. Tickets are available. Also, still have some sponsorship spots and workshop spots that would love to have you. And then if anyone is here, the organizers, if anyone has a tool to show the scheduling on the website, please talk to me. Thank you.
Thank you, Tadeo. Next, we have India. No problem. Big round of applause.
Hey folks, I'm Divyanshu. I work at Devfolio, and I would like to invite you all to ETH India, which is an event we are co-organizing with ETH Global. And yeah, so this is an event. It's going to be Asia's biggest Ethereum hackathon, and the focus is on Asia, not just India. And one core reason why we partner with ETH Global is a lot of ETH Global events are in the West. We would want that same experience in Asia, and this will be easier for a lot of folks to attend, right? So that's what we want to do. It's happening in December 2nd to 4th. And yeah, we're kind of just going through the planning phase right now. I just wanted to share this artwork. We are really proud of it. But yeah, it's going to be big. It's the third iteration. We started in 2018. We did it in 2019. Then the pandemic happened, which was a blessing in disguise because the ecosystem has really, really grown now. In 2018 and 2019, we had around 200 folks show up. But now in our programs, we see thousands of folks applying and trying to get in. So this one, we are trying to invite as many people as we can. We have capacity for over 1,500 folks. So anyone who's looking to get in, I'm happy to host you in India. It's going to be fun. It's going to be a 48 hours long hackathon, 36 hours long hackathon with workshops. So we are onboarding partners. If you're interested in being a partner, we are doing that. If you're interested in just hacking, just want to welcome you all. It's happening in Bangalore, December 2nd to 4th.
Woo. Thank you. Now we have ETH Malaysia. Jason.
Hi everyone, my name is Jason. I'm from Malaysia, and next year, 8 months from now, we are organizing Malaysia's first Ethereum event. It's called ETH Malaysia. How do I do this? The green one. Right, so ETH Malaysia is inspired actually by Shannon and Joshua Lapidus, who organized ETH Denver. So ETH Malaysia is going to be a fork of ETH Denver. It's going to consist of a hackathon, which we are in talks right now with Sozu House to run the hackathon. And so that we can, they have very interesting ideas to basically increase, the quality of the submissions of the hackathon. Also, we'll have a conference and we'll have fun activities as well. The location is going to be held at the Petronas Twin Towers, which we took 6 months to secure. It's going to be surrounded with a lot of greenery, and we want to really make a big statement, in Asia for this event. So the goal is to basically onboard new people, in Southeast Asia, and to show them and put a focus onto public goods, that Web3 is more than just about, just price action. And we only have one ask. Just one ask, which is that one of my teammates is here. This is, her name is Bowie, right? And this is her first DevCon that she's ever attended. after attending the opening ceremony, she fell immediately in love with Aya Miyaguchi, right, with her speech, okay, about subtraction philosophy. And I think, okay, that I know it's only 8 months, I know it's 8 months away, but I think it would really mean a lot, okay, if we could, if the Ethereum Foundation is here and can show us how we can invite her and confirm her as a speaker on our main stage. All right, that will make Bowie really happy. Thank you very much, everyone. See you in Malaysia next year.
Well, hey everybody, this is not end of the segment. I have another thing to show. So obviously, as I said, I just woke up, so I didn't prepare slides, but we are again organizing ETH Prague. This year was the first time we organized ETH Prague as one of the kind of major gatherings in Prague or Central Europe after Devcon IV. The event is focused on sustainability and is solarpunk themed, so we are focusing on urbanism and overall sustainability, not only like the material one, but also just the systemic sustainability of how you build social systems that can last. Next year, the event is happening in June. I think the dates are set to June 9th to 11th. And it's also going to be the last time we as Paralelní or the Institute of Cryptography crew are going to organize ETH Prague. Afterwards, it will be free for like any member of the community to take it over. But the reason for that is that with the event, we don't only want to gather the Ethereum community, but we want to bring new people who are coming from the sustainability background, let it be academics, let it be sci-fi writers, let it be practitioners, to come and teach the Ethereum community what's actually, or what are the root causes of the issues that we are facing. Next year, there'll be the last time that we focus on the Ethereum community specifics, and we'll be labeling the event as ETH Prague. And the year after, we actually want to invite all of the members of the Ethereum community to come to a new event, which will be solely focused on the solarpunk values and on sustainability as such. So if that's of your interest, please show up to Prague in June. Thank you.
Thank you, Joseph. Now it comes Spaghetti. Green. Big green, big button. There you go. Turn it on.
1, 2, check.
Sorry. So yeah, so Spaghetti was born last year, and we had the first event. What is Spaghetti? Spaghetti is basically an umbrella for and like an accelerator for the Italian communities in general. And we started last year in Milan, but we are planning to do each event in a different city in Italy to include all of the Italian communities. And so it is an event, but it is also an educational network. These are some pictures of last year. We had 400 participants, so it was not super big. And it was both builders and non. And it was good because we started actually 2 new communities in Milan that probably will organize also ETH Milan. But for us is something bigger.
So something that we just released is a new website. So also thanks to Marco and Simone, it's a sort of interactive map where you can choose and find your own regional communities, and also by doing a pull request on a GitHub, you can merge new communities if you want. Please click. And yeah, what's next? We will have a midterm event in January in Rome, a one-day educational thing for university students of computer science, economics, political sciences, etc., run by the Spaghetti community. Spaghetti #2 will be very likely happening in southern Italy. There's a few candidates that we will spoil in a few weeks. May 23, 1 week of events. And yeah, we will also reach out to the EF to run a quadratic funding round for local implementation of public goods using Web3. Thank you very much.
Complimenti ragazzi. Grande Marco. We would like to learn more about how this map works. This should be open source, I guess. For every, I imagine like Colombia having there. So we have, so big round of applause for Kim from Vietnam. So I hope I'm pronouncing your name properly. Woo!
Hi everyone, my name is Queen. So I'm present for ETH Vietnam. So even though I'm here alone, but I present for the whole community. So maybe we are the youngest community. This is the first time we do ETH Vietnam, but who are we? We have 100 million population. We top 3, like, you know, market for crypto user, about 8 to 10 million crypto user in Vietnam. We have the very young dev community who are, you know, like even the young dev like Vũ, he born in 2001, also like study English by himself, live in the rural area because he wants to study ZKP, and now he also like working for EF. And another dev guy also like he also like working for AI, also born in like 2003, and now also like building the AI machine learning, applies ZKP, and also mentored by Barry Whitehead. Also we have many top dev also from great projects like RC Infinity or Kyber Network or Cypher, and we all hunger, you know, to build the great projects. So that's why we want to do ETH Vietnam, and this is the first time that we built. And also for ETH Vietnam, we're gonna do, you know, like building in the Independent Palace, which is one of the most like historical building for all the government. Also have the, you know, meetings with the important like diplomatic and other government. And we're gonna do it in November from 25 to 27, this year, the first time. And we have the hackathon. We right now have about like 70 team joins registered for the hackathon already. We also have the demo day. We also like, you know, do a lot of prevent workshop, more than 40 workshop focused on layer 2 and dev committee. Hope to see all of you guys there. And also we gonna do it like next year for ETH Vietnam. And you know what, like, you know, right now we also the strong candidate for Devcon next year. And we hope that all of you guys will vote for Devcon Vietnam next year. Thank you.
Woo. Thank you so much. We have next for Warsaw. We have Ant here. There you go, guys. Wow, the whole team. Yes. Yeah, go for the photo. Oh, did you add the slides, guys? But do you have the slides there? I would love to.
Hey guys, my name is Antoni. I'm with the eForsto team. And we're here to tell you about, sorry, yeah, well, it should be there. Yeah, here we go. Yeah, so the story of eForsto begins almost exactly 1 year ago in Lisbon, out of all the places. We went to ETH Lisbon with this great group of people, mostly Web3 engineers, and we were surprised about how many Polish engineers we met in Lisbon. Turns out that there's a huge community of Web3 builders in Poland, but we didn't have a chance to meet them, so we decided to build a community for the Web3 builders in Warsaw. The community was really fragmented, and I think Warsaw really deserves a place on the global map, on the global Web3 map, so that's why we're doing eForsto, and Marcin will tell you more.
Yeah, hey everyone, my name is Marcin, and yeah, we are after the first edition of eForsto, which happened this September. Some of you have been over there. I heard a couple of good feedback, even during Devcon, which is extremely rewarding. You can see like our team is super engaged in the Web3 community, even over here in Bogotá, which is like 14 hours away flight from Poland. We get over here like with big team. Huge shout out to Shannon and the whole ETH Denver team and ETH Lisbon team for huge help. Like their support was extremely valuable for us. But okay, we don't stop over here. So what's going to happen next? We're going to have like in real life monthly meetups, every month a meetup, mostly like with a dedicated topic, let's call it ZK Sync, ZK rollups, DAOs and so on. Workshops for students, but not only, like mainly technical ones. You know, like Polish developers are top notch. And yeah, like next year, 2023, we are also going to have our main event, which is ETH Warsaw, or maybe even Warsaw Blockchain Week this time. We have a huge interest, so might extend it even more. It's going to be second or the third week of September 2023. And yeah, as I said, like monthly meetups, ID student workshops, online. Oh yeah, and on top of that, we are going to have like an online hackathon and one-day summit in spring 2023 to warm up the community a little bit more. So if you're interested, you can scan the QR code over here. There is a form to sign up for news about the next edition, and you can follow us on Twitter at ETH Warsaw. Yeah, thank you, and hope to see you in Warsaw. Like, do zobaczenia.
Thanks, guys.
You have still 1 minute more if you want to shield something else, because we still have like 8 minutes. We got all the
I guess we're the
presentations
lucky
done.
ones to get the time. But yeah, I mean, pull out your smartphone and scan this QR code if you want to be part of ETH Warsaw, if you want to attend any of the events, if you want to become a sponsor or speak at some of our events. A little insight from the sponsorship side. Our sponsors were really happy with the hackathon submissions quality. So that speaks a lot to the skills of Polish Web3 engineers. Marcin, would you like to add anything?
We have good swag, yo.
Yeah, I wanted to say that. I want one of those hoodies.
Oh yeah, and we have like, oh, forgot. We have free T-shirts, like ETH Warsaw T-shirts that we can distribute. So if
Where? The guy who is with the
where the
orange T-shirt? Ah, do you have that? No, you just want that. Ah, okay. I thought you were the one who was going to.
Okay, so we are going to distribute the T-shirts. Like Antek is going to be the one for everyone who is like willing to get one. They are L size.
Woo!
Show your enthusiasm.
Let's use these 2 minutes to take a photo together.
Ah, for sure, you can take a. Yeah, all of the organizers. Yeah.
The whole community that brings ETH events globally.
Yeah, I didn't introduce myself. I'm Juan David, and I didn't have the time to add the ETH Latam, so this is something quite interesting that's going in the region. So I would love also to chat with all of you later of all the things that we can learn. Marco, no, we want the open source map. People are already asking for that. Each country should have one of those. Oh, okay, share the GitHub order. Thank you so much. Oh, Eleanor has something to add.
I forgot that, well, it's a bit different. We're trying to, so it's going to be a conference hackathon, and we want to invite all previous winners of Ethereum hackathons to compete in a All-Stars Champions League model. We're still brainstorming on the format, but I'm very tempted to make them start 1 month earlier and then present on a special track for the All-Stars hackathon winners. Thank you.
How can they find you? ETH.crypto canal. Could you spell that? Crypto with Y, canal, C-A-N-A-L, canal. There you go. Thank you so much. That was our Ethereum event showcase. Thank you, Joseph.
Thank you, Juan David. So in the next 5 minutes, we are going to start a layer 1 protocol track, and the next talk is going to be on light clients after the merge. So in 5 minutes, if you're interested in that, please stay in the room. If you want to talk to the event organizers, I'm sure they will be around. You can meet them outside of the room or catch them after they leave the room. Thanks, everybody. Are we there? Yeah. Hey, everybody. Welcome to the Cold Forest stage for one of the Layer 1 protocol talks. The talk is going to be about light clients after the merge, presented by Ethan Kissling, a client engineer from Nimbus. So please welcome on stage, Ethan.
Hello. Hello to my presentation about light clients after the merge. So many of us are asking ourselves, what is a light client? And to answer that, first let's look at what you actually need for a full node. At the very least, it's a Raspberry Pi, 8 gigabytes of RAM, 2 terabytes of storage, 1 terabyte a month internet. And a light client is basically anything that doesn't support those specs, like a browser wallet, to the left side, MetaMask, or in the center, the status mobile, or on the right, hardware wallet. So let's look at what those light clients can actually do. Let's assume that you own one of those, this MetaMask wallet with the 4.75 ETH, and you are doing great work at this conference, and your work is so great that you're approached by investors. Here, someone approaches you, he wants to donate 0.5 ETH to you. So, sounds good, 0.5 ETH, a lot of money. You give them the QR code, they send the money, and they send you the transaction, and so seems good, but when you check it, you see, they accidentally sent 5 ETH. So we need to refund 4.5 of those, and luckily we brought our hardware wallet, but as you know, the Wi-Fi is not too great here, so let's just ask if they can use their laptop. And they agree, we connect the ledger to their laptop, and we see here the 9.75 ETH, so the plus 5, and we sign the transaction for 4.5. The ledger protects our keys, so they cannot be extracted. We see here the amount is correct, the address is correct, and we confirm, and we thank them for the donation. So, light client's very powerful, but there is a problem. When you go back to the hotel, you actually realize that this transaction of the 5 ETH is missing. So, what went wrong? We confirmed that everything is correct, but one key piece is missing there. The actual balance was 4.75 ETH, so they lied to us with the 9.75. This is actually the same problem with traditional banking. When I create a transaction to an unknown destination, they only ask me, is the amount correct and the address, but they don't verify that the intent, why I am sending the transaction, is really why, So where is MetaMask putting this data from? The answer is, there is a setting in there, and you just put it to a server. By default, that's in Fura, but in this case, the scammer just put a custom URL there that lies about the balance. So how is that possible? Isn't that more secure? Actually, it's just, this is the call that MetaMask is doing, ETH balance. You pass it the address, the block number, and in the response, you just get the raw balance. No security whatsoever, just trust me, bro. So in this case, the attacker simply added the 5 ETH. If it's our address, this is the complete attack code, this thing I tried with a real MetaMask. So now the question is, how can we make this more secure? To understand that, we need to see what is actually stored on Ethereum. And all of these things, any one of you probably interacted with at least one of them. NFT ownership, game characters, tokenized assets, exchange rates, or even just the plain ETH balance that we have seen before. All of that is just data stored as part of the Ethereum state. And because it's data, it's just a bunch of bytes, and we can arrange it as we want. For example, here, we can order it. And then what we can do is we can compute a hash function on pairs of each of them. So a hash function is just a one-way function. It's a cryptographic checksum. The idea is that if any of these change, for example, if someone modifies the B, then the hash also changes. And we can apply this to the entire data. And as you can see here, we now have only 4 of them. Then we do it again, we only have 2 of them until we have a single state root hash. So how is this useful? If we have our balance down here, the 4.75, we can see the root hash contains information about all of it. So whenever someone changes that, for example, to 9.75 to lie to us, everything changes up to that root hash. So if we know the correct root hash, we can know that whether something was tampered with or not. So how do we actually send a proof that the 4.75 ETH was used as part of this hash? And for this, we need to walk this entire path to the top. Let's start with this node here. To compute that, we also need this one. And then we go to the next node here. And for that one, we need the A and B. And then from there, we go all the way to the top. What is missing is E, F, G, and H. So with just sending those 3 additional values, we can prove that the 4.75 is part of the root hash. We can cut away all of the rest. So those proofs are really tiny. Of course, in reality, it's not just a binary Merkle tree. It's a bit more complex, but the general principle is the same. So how do we obtain those proofs? The answer is ETH get proof. The interface looks surprisingly similar to the get balance, but instead of just a balance in the response, we also receive the Merkle proof. And this Merkle proof can be used to verify that the balance that we get is indeed part of that root hash. So now the question is, how do we obtain the root hash? This is where the Light Client protocol comes in. If we look at the beacon chain, it's a series of blocks that point to the parent block with an address that's part of the block. It forms a chain. And since the merge, actually, the root hash is just part of those blocks. So the question now is, how do we obtain that latest block with the correct root hash? And a full node does this by just following all the signatures and verifying them. We have the proposer of each block and then all the attestations. But to verify that, it's like nearly 500,000 of validator keys, and it takes multiple gigabytes to verify what is the latest block. So that is not very practical for Light clients. But a year ago, Altair launched, and it added this notion of a sync committee. A sync committee is a set of just 512 validators that the Light client can keep track of. And they also sign each block. They sign whatever is the latest block. And if you know those keys, you verify this signature, and more than 2/3 of it agreed on the same block, you can trust that it's the same, that is correct. So how do you get these sync committees? And the answer here is, it's from the previous sync committee. Every day, the sync committee changes. And the previous sync committee signs a message that passes on this power of signing the latest block to the next sync committee. And the previous sync committee, how do you get that one? It's from the previous sync committee, of course. But at some point, you just need to agree on a trusted block route, for example, the merge transition block. And if you start from there with the initial sync committee, you can get that with a Merkle proof as a bootstrap object. And from there, you can continue one day at a time to the next sync committee, download those public keys, verify the message that signs the next sync committee until you are at the present one, and then you obtain the latest block, check the signature, and you know the root hash. This data is really small. It's just about 25 kilobytes each, and to obtain the final root hash, it's just about 300 bytes. One thing for certain applications that can be done, if you are really offline for a long time, those committee messages can be combined into a ZK proof, and then you can essentially jump from any point in time to the present in constant time with a very small proof. Those APIs are available to download the data. It's on REST and libp2p. It's already standardized, part of the official specs. On the Portal network, there is a PR, and Lodestar and Nimbus are currently implementing the libp2p and REST APIs. So if you want to try those, feel free to do so. Then security, how secure is it? There is some research that shows that with a few minor modifications to the protocol, it can be made so that you can actually only sync every 4 months. So this really opens up a lot of applications, such as IoT devices where you are not connected to the internet. So as long as you sync once every 4 months, should be secure. Then let's bring it together. This was where we started. We had our wallet, just get balance to Infura, and it returned us the 4.75 ETH. Not very secure, but it's the best that could be done before the merge. Now we can obtain the latest root hash from the Beacon API and then use the getProof endpoint to actually get the 4.75 plus a proof that it is actually part of the root hash that we obtained. And this essentially means that if you think that the Beacon API provider could be the same as the Web3 API provider, why not? Infura could essentially just provide that data, and you no longer have to trust them for the correctness of the data, but just for the availability of the data. That is quite huge. Like, if you don't want to modify MetaMask, you can also put a proxy in between that does this translation. So MetaMask is unmodified. It still does this old get balance call, but the verifying proxy, it keeps track of the latest root hash using the light client data, and it translates the get balance call to the get proof and verifies that the returned data is correct. It can alert you if it was tampered with, like in our original case. This verifying proxy is available today from Nimbus. It's a part of the Nimbus ETH1 repo in the lc_proxy subfolder. And yesterday, someone announced on Discord, ETH R&D in the Light Clients channel, a product called Kevlar that also does this, including proof verification for NFT ownership and token balances. So one piece is still missing for the Ledger device. How can we get it to show us the current balance? Of course, that needs a modification to the Ledger software, but it could be done in a way where we just dump all of this data to the Ledger, and it can actually just verify that it's correct. It uses the light client data to update to the latest public keys, then obtains the latest root hash, then verifies that the balance that we give it is correct using the Merkle proof, and then it can show this. It can show the balance with the timestamp, and you can verify that this transaction is really something you want to do. So what else can we do with this protocol? For full nodes, right now it's always a bit tricky. Where do you obtain that initial state from? Usually, you just go to Infura and grab states finalized. And then maybe you go to beacon chain and check that it's a correct one. But with this protocol, you can just hard code the merge transition block, for example, into the client, and then use the light client protocol to jump to the latest state, download that state, and then use that as your bootstrap checkpoint without having to validate it against beacon chain. Or another use case, a decentralized wallet that doesn't need to talk to any server. Geth has a mode called LES. Currently, it's sort of a thing that you have to enable, but the key point is that it doesn't require a huge database. So what the light client protocol gives you is access to the block headers, and inside of the execution payload header, there is a field called logs bloom. And with that field, you can filter all the incoming transactions and see whether a block contains a transaction that is interesting for your wallet. So you just need like the little light client on the consensus side, 25 kilobytes a day, about 20 bytes per second to follow the blocks continuously. And then you can pass the headers over to Geth LES, and it can then filter for the blocks that contain interesting transactions and just download those few blocks. It's not every block, for sure. So if we go a bit farther to the future, layer 2s are getting more important. And for them, the problem right now is they get hacked all the time. Like, they usually get operated by Oracle nodes that are trusted. There is a multi-sig, maybe 5 out of 9, 4 out of 7. But it turns out that one party owns 4 of those. So when they get compromised, everything gets hacked. And if you add this light client protocol there, it can sort of act as an additional safety net so that the Oracle nodes cannot just send a bogus information. So for example, when you make a deposit into a bridge, you can create a Merkle proof that you made that deposit in the Ethereum state. And if there is a light client deployed to that layer 2, you can then use this as an endpoint. Like if you submit a Merkle proof to that bridge, it can verify using that light client that it's a valid deposit and can transfer that tokens to the layer 2. And also, Internet of Things devices. You can put a rental pass for bicycles in your wallet on chain, like a weekly pass, and you can just send this data to the bicycle log, like we have seen with the Ledger device before, and it can actually verify that you own that rental pass and are allowed to open that log. Or for example, when you have like an electric car charger at home and you want your friends to be able to use it, but not anyone to be able to use it, just put a light client on there. It doesn't need to be connected to the internet. So yeah, that's all from my side. This is the latest updates about the light client protocols. Feel free to contribute to this Discord channel from ETH R&D. This is where we discuss the light clients.
We also have time for questions, if anyone has a question. There is one in the back.
Hello, thank you for the great talk. I see a lot of FUD from Bitcoin maxis who say that it's putting too much pressure on the nodes while you're part of the sync committee. So I just wanted to ask, what do the resources of the machine look like while you're part of a sync committee, CPU, RAM, and bandwidth?
So as part of the sync committee, you are already doing extra work. So doing this extra light client work is actually not that much extra. Basically, what you need to do is you need to hash the state, and you need to grab a bit of static data out of it. Because you already loaded the state, getting those hashes is basically instantaneous. So this really just doesn't add that much. For Nimbus, we collect the light client data by default, and no one has ever complained about any CPU spike or bandwidth spike due to that.
Thanks. Do we have any more questions from the audience? There's one here, the second row.
Could you please elaborate on what this means for wallets, like MetaMask or Coinbase or Ledger? Like, what does this actually, what's the future opportunity of using light clients, and how does that change how wallets actually operate in the future?
I'm not sure if I got the question, but MetaMask right now, it has to use the get balance endpoint because that's just what was available before the merge. With this, it can actually provide a secure, verified display, so to say, so that the balance that it shows is actually correct. Also for your NFT balances, NFT ownership, anything can be verified.
Is there anything the protocol can do to be even friendlier to light clients, or are we pretty much as good as it will get?
We are still working on the protocol. For example, right now getting access to the execution payload header is not that easy. You still need to download the full block for that. But we are targeting a couple improvements there for Capella that further reduce the amount of information that needs to be exchanged to be fully synced to the latest head. Front row. Oh, or back there.
Oh, hey, thanks for the talk. I just have a question about the attack that you showed at the beginning with MetaMask and the solution that you came up with at Nimbus as how to mitigate that attack. I'm just curious, and excuse my ignorance here on this question, but like why doesn't MetaMask or these like client wallet providers just build a solution and instantiate it themselves? Like, what does Nimbus, why does Nimbus need to be brought in to mitigate this attack?
Well, the reason there is that actually those protocols just are getting standardized right now. For example, the REST protocol was standardized on Monday. So that's when it got merged. So there was just not enough time yet. And we hope for sure that MetaMask and Ledger will integrate those security enhancements directly into their products. Or you could also imagine a scenario where Apple and Google put it into the Android and iOS operating systems as a background service. So you can just ask that one, give me a secure balance. And as long as you trust that background process, that's fine. But yeah, the answer is just there was not enough time yet to implement those changes because the protocols are really brand new.
There was a question in the front row.
Hey, Zan. What are the sort of assumptions that are being made or the security implications of just trusting the data that comes into the light client headers, and how do we mitigate this?
So all of the security implications, the sync committee is sampled by random from the full validator set. So the full beacon chain currently operates under an honest majority assumption. So as long as a majority is honest, the beacon chain works. So if we sample randomly 512 validators from that set that is considered to be honest majority, then the same can be assumed for the smaller set. And there is also this additional safety, that's why it's more than the weak subjectivity period, where because like it has to be exactly those 512 validators that are only assigned for that particular day that you need to compromise. If you look at it, how long does it take for validators to exit? It takes about 4 months until enough validators are exited so that they can then sign conflicting histories to compromise this. So as long as you stay within the 4 months, and as long as we improve the protocol with those slashing methods, then I think it's quite a secure way. What you have to keep in mind, though, is that the Sync committee is 512 validators, and each of them has 32 ETH. So if you combine all of these balances, it's about $2 million. So that's about the highest cost you can get. Even if everyone would be fully slashed down to 0, any attacker who can offer the Sync committee a higher amount than that can compromise this. So right now, for highly secure applications such as layer 2 bridges, I would recommend it as an additional safety net. So in case the Oracle nodes get compromised, that you can still verify that they are compromised. But I would not trust this solely for high security. For the wallet use cases, it's already an improvement compared to just trusting in Furon.
One last question.
Hey, so on the beginning of the talk, you mentioned this Raspberry Pi 4 with 8 gigs and 2 terabytes of disk. So is that still the same for like a running a light client? Could be a bit lower to smaller devices running Linux in constrained like a hardware resources?
A light client doesn't need a database. You just have to track those 512 validator public keys and the latest header. So you don't need 8 gigabytes of RAM. You don't need 2 terabytes of storage because there is no database. And you only need 20 bytes a second over 1 terabyte a month. So yeah.
Awesome. So please, one more round of applause for Ethan. Thank you. If you're interested in the topic, catch Ethan outside of the room. And in the next 5 minutes, we are going to have Dan O'Farron on stage talking about compatibility of Ethereum tooling and with other blockchains, alternative blockchains, and what it can teach us about Ethereum's future, starting in 5 minutes. can teach us about Ethereum's future by also one of the cool people in the space, Dano Ferrin, the principal software engineer. Oh, please, yeah, one round of applause for Dano. Dano is a principal software engineer from Hedera Hashgraph. He's also the maintainer of the Hyperledger Besu. So please, without further ado, Dano, come on stage.
Great. These are my slides. So the title, this is what happens when you forget to name your talk 5 minutes before the finale. So it's probably just a look at the future by looking elsewhere. But that's pretty much the point of my talk. I thought, you know, other chains have gone before Ethereum, and they've done different things in Ethereum, and we've adapted things. And so as Ethereum is moving forward, we should look and see what's worked with them and what hasn't worked with them. So the thought I had is some of these chains are trailblazers, and some of them are shipwrecks as warnings to don't go there. So I thought I'd ask DALL-E, to the AI generation program, to create an image of me, of a covered wagon on a seaside, looking out over a shipwreck. And what I got instead was something more awesome. I got this. Over here you see a broken down wagon that's broken. This is the real wreck. And this isn't a ship. This is a wagon that's converted its cover into a sail. So this isn't the East Coast if you're heading west. This is the West Coast. They made it to their destination. But this wagon is learning from other systems. It is adapting. It is getting ready to set sail and head even further west. So how to read this presentation? Most of these slides are going to be in 2 columns. On the left is going to be what other chains do and some of the details that are relevant. And on the right is what Ethereum can learn from it. Sometimes we learn good things. Sometimes we learn things not to do. And sometimes that's just a neat thing to know, but it really won't work for Ethereum. And I kind of live in both worlds on this. The reason I came up with the idea for this talk was I work at Hedera Hashgraph. I was one of the maintainers of Hyperledger Besu, and they wanted to improve their Ethereum compatibility game. So the idea was, well, Hedera is Java-based, Besu is Java-based. Let's just componentize out their EVM and bring it into Hedera and bring that software over, and suddenly, boom, 100% EVM compatible. It's not that simple. There's a lot more to it than just reading bytecode and executing programs. So I'm going to talk about 3 separate areas. The first area is going to be accounts and cryptography. Then I'm going to spend a little bit of time on the EVM itself. And then I'm going to talk about transactions and transacting with Ethereum, which is kind of an important thing. If you can't put your transaction on a chain, the chain may as well not exist. So the first thing to talk about on the accounts is the cryptography. Accounts in Ethereum are intrinsically tied to your public key. And a lot of other operations are intrinsically tied to hashing operations. Nearly every different chain out there has a different setup for the encryption that it uses. Ethereum uses ECDSA on SECP 256K1. Hedera uses Edwards, as does Near. Polkadot uses a combination of Schnorr and Curve 25519, which is pretty unique and sensible. And the consensus layer uses BLS 12381. And there's a lot of variation in there. And then you look at the hashing algorithms. There's an older draft of SHA-3 called Kachak that Ethereum uses. Then there's actual SHA-3, which Hedera uses, but they use more bits. Near uses SHA-256, as does the consensus layer, and Polkadot uses Blake 2. So one of the things looking at this is you might think we can just pick one and go with it. The problem is cryptography needs change over time. Attacks against cryptography don't get worse, they only get better. New ideas get found. One of the big things on the horizon is quantum resistance. If we want Ethereum to last 10, 20, 50 years, at some point we're going to have to change some of these algorithms, and at some points we're going to have to do significant changes. So we should continue to build with this in mind, that we're going to want to change it. I mean, as it is right now, we may want to change it to use, wrong button, this is the laser. We may want to use BLS 12381 for some of our accounts. It's not just useful on Ethereum mainnet, on the consensus layer, for aggregating signatures, but it's useful on layer 2s for aggregating all of their transactions into one signed transaction. Now that comes along with some problems. BLS and Edwards require you to bring the public key along with you. I think that's covered by the next slide. I'll talk about it on this slide. So The BLS and Edwards require you to bring your public key. ECDSA doesn't. So we need to put more space in some of these transactions and normalize the practice of sending your public key or your Ethereum. And you can't send your Ethereum address. You actually need the public key for the cryptography. So for some of these signatures, we would need to socialize that. So the next interesting issue comes along with the account addresses. Hedera uses a sequential system, counting up from 1,000. Hedera is introducing an alias system into some of its accounts to support some of the needs of Ethereum mainnet. Create 2, you have to use the Ethereum equivalent address, or things like Uniswap just won't work. We're also considering multiple accounts per model. But some of the interesting things here is that by disconnecting the public key from the address, you can do things such as key rotation, which is critical to some enterprise applications. But right now, your key is tied to your address. So account abstraction is a way to solve this. I think will be a great way. But another problem with compatibility is if we're going to use a different key address, do we do address translations to Ethereum? Do we have definitions for these? We'll probably need some sort of a definition for how you would take a BLS 12 signature into an Ethereum address if we're going to adapt that for various uses. And the biggest problem is in ethers.js and some of the other tooling. When you create a contract from an account, they don't check the return value. They assume that you're following proper yellow paper definitions, which for an Ethereum tool makes sense. But with the possibility on the horizon that some of these signature algorithms might be changing, that's not an assumption that is safe anymore for these tools to make. They should believe what the RPC tells them is the new address when it comes back to them. Another problem is authorization. EC Recover is used by a lot of contracts to authorize messages, like 0x to authorize the trades. Some other DAOs use it to validate votes and everything like that. But this, again, ties the account to the key and also precludes key rotation. Hedera uses sequential accounts, which doesn't work well with EC Recover. We have to map in an address to that. Near uses usernames that you have to register ahead of time. Quite different. And so we need to have a different approach to this. We probably need some sort of an account authorized precompile to be brought into Ethereum when we do account abstraction. So you can ask a question of here's an address, here's the signature, and here's what they signed. Is it authorized? And then just return yes or no. So I think that would help us continue to keep EC Recover as a primitive and move the questions about am I authorized into a precompile that has deep integration with the system. And finally, account abstraction. One thing we should learn from Hedera on this is Hedera accounts that used to have to create them before you could send crypto to them, which presented lots of problems for exchanges creating new accounts for customers, or for somebody saying, hey, send it to this public key. You'd have to have the account created before anybody could send you your NFTs or your crypto or anything. So Hedera introduced a system where you could have an alias fee account, and we would create the account under the covers for you late, the moment we need it. And the lesson here is from the account abstraction. This was a bad experience, which is why we had to add the aliases. If we're going to have account abstractions, we need to have a mechanism that you can convert an existing end user account to an account abstraction account so people can still send you stuff ahead of time before you create your contract. Hedera's got a unique process called hollow accounts that we're implementing here shortly, where you can just set it with partial information and then fill it out later. And that's kind of what would need to happen in account abstraction. Some drafts have this feature, some drafts don't have this feature of account abstraction. So whatever approach we take, I would really want to be able to convert an end user account into an existing externally owned account into an account abstraction account, rather than requiring them always to start from a contract deploy. So that covers it mostly for accounts. The next area is the Ethereum virtual machine. Even though you bring in the same library, there's always rough edges and corners that you need to deal with. One is the issue of ergonomics. And precompiled contracts is the way that most change solve this issue. What if you need to do stuff that you can't do inside the EVM? What if you need to queue up a layer 2 withdrawal? What if you need to interact with your native token system? What if you need to change your account information from a smart contract? Lots of smart contracts, lots of different blockchains have different addresses for a lot of their precompiles. An interesting one down here is Cello. This is actually the precompile that was the BLS signatures that was in Berlin before it was removed, before we shipped it to testnets. The difference is there, they put it at a different address. which I think underscores what my main ask here is that we probably need to organize a registry of precompiled contracts that all chains and layer 2s use. For one, to make sure there's no collisions, and for two, to give proper documentation and utility for smart contract writers so they know how to call these contracts within it in kind of a centralized place. But I also want to pitch a language change for these contracts. There should be a difference between a precompiled contract, which is a contract that you could do everything within the EVM. Most crypto primitives would cover into this. You just can't do it efficiently. You can't do it speed-wise. It costs too much. So you precompile it into a library and you do it cheaper and faster. The other type of contract would be a system contract, where you're breaking the layers of the Ethereum virtual machine and going and doing things into different parts of the system that you can't do in the EVM. So most of these contracts up here I would call system contracts, and only the BLS signatures I would really call a precompiled contract on this list. A little bit here, we had to do something different. Instead of RANDAO, we used a different hash. And Hedera has a very complex fee system. It works, you just librarize it, gets lots of tests. And the takeaway from that is that multidimensional 1559, much simpler than what Hedera has. And what Hedera does isn't too scary if you know what's going into it. But some end users, it's not quite as simple as here's one price and here's 1 meter. Numbers go up as you do more. So I think the multidimensional 1559 would be a good value. And I don't think we're going to be charging too much for a lot of our gas features, but if we do, we should consider letting some operations be charged with Ether rather than charging gas, because if you're just going to take up a lot of memory space that you're not doing a lot of compute from, there's no reason to keep the whole blockchain shut down just to do one large operation that takes no compute. Not too big of an issue. Off and off call. I don't know that anybody that does this. So this isn't a fair take, but it would be evidence we shouldn't do it. I'll come back to this later, don't worry. The next thing, though, I'd like to use this as a little example. I'm going to tell a little parable about this. In a lot of things that you're interacting with in smart contracts and in blockchain, sometimes you don't know if it's really going on anywhere, if it's going on under the system inside of it. So here's a little scene from Westworld Season 1, where Billy is going in and says, like, "Are you real?" And the very pithy comment that comes out that kind of shapes the rest of the series is, well, if you can't tell, does it matter? The substance that you're interacting with doesn't matter nearly as much as the surface you're interacting on. So this is something that we did in Hedera. Hedera has a very rich token system that has zero connection to the smart contract system. This is how they get their 10,000 TPS number on token trades, is they just completely bypass the EVM. But there's a lot of use cases where you may want to interact with your smart contracts to interact with your native Hedera tokens. So what we did at Hedera is we took the addresses of the tokens and we made a little jumper contract. You call into it, it'll immediately jump you into the HTS system contract and do whatever you would need to do. And from this, we could make our HTS tokens look like you had deployed an Open Zeppelin ERC20 or ERC721 contract. And it worked great. We plugged in some Uniswap derivatives. We plugged in 0x protocol. In some of our MetaMask testing, it just magically worked. And none of this was running EVM code. So the takeaway from this is it's only the effects of what happens in a lot of these systems that matters. Clients can do things if they really wanted to. They could precompile the Open Zeppelin contracts if speed is the issue. And this is honestly what ZKEVM proving is using in the system. And it's the side effects that matter, and I don't understand the math, but the math checks out. And so that you can take that same approach to the EVM. I don't understand the EVM, but the side effects check out. So you can pull this in later in all sorts of other systems. Finally, transactions and transacting. This is probably the last hurdle that we had to overcome to really up our game at Hedera for Ethereum compatibility. We had to adapt the Ethereum transactions into Hedera transactions. I'll go through this in some of the slides. But first I want to talk about, before I get too deep into the transactions, a little bit about Hedera's consensus mechanism that really drives a lot of its features. Hedera uses a consensus mechanism that fully separates ordering from execution. And the way they do this is because of the nature of the asynchronous BFT hash graph algorithm. The algorithm works by all the nodes gossiping together about what transactions they've seen, and they include a link to another transaction, to another node's previous hash in gossip. Eventually, you can get to the point where you know what all the other nodes have seen and what they've signed and attested to, and you can come to a conclusion about when transactions reached the majority of the other nodes. And you can take an average of when it came, and that's your timestamp, and that's your absolute total ordering. So we can order these transactions without even seeing what's on the inside of them. Now, one of the great things about this is there is no leader that comes out of this process. So when people say Hedera is not a blockchain, it's probably better to say that there's no block producers in Hedera. We don't go into a memory pool and pick and choose our favorite transactions and put them in there. You get the order that you get. And this allows us to, and this is kind of the trick behind how we get our amazingly high TPS numbers, is we're running the EVM full time. You know, the basic EVM is not the fastest. That would be EVM 1. But what we're running is if we run it all the time, we can overcome a lot of those barriers, and we can get that transaction. And that's even 15 megagas per second is even us holding back and having some safety features in there in case we get overloaded in other parts of the system. Now, the problem is this really doesn't apply to Ethereum. Blockchains never change their consensus algorithm. Well, almost never. And Ethereum mainnet just changed theirs over to proof of stake. And a lot of things about the culture are falling out from this. MEV is accepted and endorsed. There's talk of enshrining proposer-builder separation into the protocol. So some of these base-level decisions come up and they affect the nature of the ecosystem. So there's not much to be said about this. This is kind of neat to look at, but it's not something that Ethereum is going to be able to change. The next thing I ran into was an issue with transaction nonces. Hedera doesn't use transaction nonces. They use timestamps, and you can do neat little tricks with your valid start time and valid duration down to the nanoseconds to ensure uniqueness for your transactions. But this is a problem that Ethereum very strictly uses their nonces. And they really use their nonces as sequence numbers. I really wish that when they started this spec, instead of calling it a nonce, we call it a sequence number. But unfortunately, that ship has sailed. In nearly every blockchain out there, when you see nonce in a transaction, you know it's sequence number. Except for one. I really had to dig deep in my memory for this one. This is a blockchain out of China that's very Ethereum-like, but it doesn't do the transaction sequence numbers in the nonces. It actually treats them as a true nonce. Great for performance and throughput, horrible for memory. So not everyone does this, but we had to adapt the nonces. The next issue was meta-transactions. We took a process where we wrapped the transactions of the Ethereum RLP inside of a Hedera transaction, and we signed the Hedera transaction with one account, and the inner account was responsible for it. This is classic protocol-level meta-transactions. There's not too much fancy stuff going on with it. And it just transparently works. The relay can agree to pay for none of the gas, some of the gas, or all of the gas. And the transaction on the inside is responsible for the rest of it once we map that transaction to a user. And if the relayer sends garbage into Hedera, we throw it away and we just charge the relayer for the garbage that they brought into the system. And it works really well, and it bounces great, and it spins like a top. So if we need to get meta transactions into Ethereum mainnet, the way to do it would be through enshrining it in the protocol would be the best way. What we have right now with the cooperative impersonation going on is a good enough way for people that want to participate. But account abstraction also has the potential to solve this problem of allowing people to pay in one account and act in another. Now, I promised I'd come back to this, auth and auth call. So it's not just that other people don't do it, it's that other people solve the problems directly in the protocol. So I think that people don't use auth and auth call as their solution, I think is stronger evidence. And I think on balance it's going to come by, even if you take these evidences out, that it's not worth the risk. Maybe we should examine payer-executor splits to solve some of these auth and auth call problems. And finally, there's JSON RPC. This is truly the last mile of Ethereum compatibility. If you don't speak JSON RPC, all the masses of retail tools and developer tools will not talk to your blockchain. So we had to write up a relay server that would stand up in the middle, take those RPC calls, send it out to the consensus layer, send it to our mirror node, and this looks a lot like the Portal network. So the Portal network's idea of having a proxy that's going to go through and talk to systems that aren't necessarily live, but have verifiable information, it's going to work great. It works great for us. So this is something that I have a lot of hope for. I've been following Piper's work for quite a while. I think it's great. And again, I think that covers most of it. Oh yeah, one last ask. This is this is my last point. Can we get an RPC system that doesn't put everything in the post body? Can we please get a REST-like JSON RPC? This has huge impacts on load balancers, huge impacts on caching, and all sorts of other items. We have to put this into the application. We can't put good front ends on it and split the balance easier. It's just as simple as putting the method name in the URL would have huge impact. And so that's one of the issues, because Hedera uses gRPC, and it's got amazing load balancing implications. But we can't quite do the same tricks that we do with JSON RPC. So in the 25 minutes that I had to talk, or the 20 minutes I was allocated, those are my conclusions of what we could really learn from Ethereum, from other networks and what Ethereum could apply. I think account abstraction has great future potential to solve a lot of these problems. The EVM, if a chain wants to really run the EVM, they will do the changes they need to. There's not too much changes the EVM needs to do. It's the user tooling that might need to change to deal with potential changes in cryptography that comes ahead. And not every chain is going to be Ethereum mainnet. There's going to be other chains that do cool things that aren't compatible with Ethereum mainnet. That's fine. Let them do their cool things. Let Ethereum be Ethereum. And if you have any questions or comments, my DMs are open. Just don't offer me a pump and dump. I'll delete you.
Thank you, Dano. We also have time for questions from the audience. Do we have any? Then please, one more round of applause for Dano. Thank you. You can also catch him outside and chase him later at the conference. In about 10 minutes, 2:30, we are going to welcome on stage Kelsos to talk about Rotkey and its mission on running an open source project. So if you're interested in that, please come back in about 9 minutes now. Next up, we have a project that many of you will know. The talk is going to be about Rotkey and why it's open source and local first and why should you care. So please welcome on stage Kelsos with the next talk.
Okay, hello everybody. Thank you for coming. Today we will talk about open source and local first and why it matters for data ownership and privacy. These are driving principles behind developing Rotkey. So let's start. So who am I? I have been doing application development, local, mobile, and web since 2010. Most of the time of this was doing open source, and I have been a Rotkey contributor since 2018, handling parts of the front end, infrastructure, packaging. So what you do in a startup, pretty much touching all over the code base. So let's start with the problem today. The problem today is that we don't have enough decentralization. A lot of the software we use daily is closed source. It runs on data centers, and there you don't have ownership or control of your data. They can use it to train machine learning algorithms, use it for whatever reason. There is no transparency, and you have to trust that they use it as they claim. They might claim that they have encryption, but you don't have any way to verify that there is no master key, and there is no way to be sure that all the claims are true. Then your data can leak. This can happen with different ways, like for example accidents. An intern got too much access, didn't know what they were doing, and all your private information is public. Or hacks, or some companies just outright sell data. There was a nice John Oliver episode about data brokers that was really scary on how much information they could get about people, even sensitive information like healthcare and the exact point where people were living. Then other problems are that companies can go out of business, and then basically you lose access to all your data. Another problem can be that they can deplatform you. Something happens, your account is locked, and then poof, all your data is gone. We can see some examples. So, for example, Dapper started blocking all the Russian users, so basically they lost access to their funds. Then we had the case of Snapchat, where employees were abusing data access to just spy on users. And as we saw, like Uber was hacked recently by a teenager. So it's easy, you know, if your public information goes out, then there is no way back. Then we had the ledger hack, like people were receiving mail at their homes, which can be really scary because their public addresses, their private addresses, the home addresses were outside in public. So let's talk about open source. What is open source? Like there are 10 criteria that define open source. The main idea is that the open source software is freely distributed along with the source code, and it doesn't limit the usage. There is no discrimination against people and against usages. Everyone can use open source software. We also have cases of software that has public available code, but it isn't open source. Some examples include, the delayed open source license that Uniswap and Aave have, and maybe MongoDB server-side public license. And in a lot of the cases, I can understand the reason behind that, because it's really hard for open source projects to fight against big companies. The reason for the server-side public license is that AWS was taking all of MongoDB, selling it as a service, and then the developers didn't have the funds, and they had to maintain and fix the issues. So why open source? There are some strong benefits building open source. You can have a strong community involvement, you can have transparency, reliability, security, And it also makes attracting talent easier, and it avoids also vendor locking. So, like community involvement. There are people around, like someone needs a feature, we might be overwhelmed, and someone with technical knowledge can come and contribute to the code base and add their feature that they want to use, so other people can also use it. The non-technical people can contribute with translations, making the app available to a bigger amount of people, or documentation, or just open issues. The code is really transparent. Like, you don't have to trust what the developer claims that the software does. You can easily read the code, or other people can read the code and verify that these claims are actually true. And open source software tends to be more reliable and secure. It's peer-reviewed, so anyone can read the code, and it's easier to spot flaws earlier than closed source. We have software we always use that is really robust, for example, Firefox, the Linux kernel, Ethereum clients, Nginx, and this is highly reliable software we use everywhere, and it's all open source. Then open source can make attracting talent really easy, because it's always easier to hire someone that you have previously worked with, you had a good interaction, and then maybe you also test your code, and you can see in an easier way that someone is a good fit for your culture, which is not always the case when doing some small interviews and like giving some kind of task. And then, like I said, you can avoid vendor locking. You always have access to the source code, you always have access to the application, you can check the data, you can access the data. So in case you want to move and migrate from the platform, it becomes really easy because you can access everything. So the biggest problem with open source is funding, because it's hard to monetize open source software. We had some major incidents, for example, where it was the Log4j hack or the OpenSSL hack clip, and what we found out of this is that you had a couple of overwhelmed software developers maintaining infrastructure critical software, and everyone using it, but they were always underfunded. No one was paying for that. And this led to huge security problems. So there are different ways to fund, but it's always difficult. For example, you can accept donations, you can have, as we do in Rotkey, you can get grants for integrations with other protocols. Bitcoin grants is something that helps us a lot to build the software, and then we have premium subscriptions, but this doesn't really work because it's hard to monetize retail. And as a small software, it's hard for us to actually have the amount of people that we would need to have a sustainable source of income. So let's talk about local first software. In local first software, you control your data. Everything happens on the machine you control. There are three major principles. So the network is optional, local data is the primary data, and security and privacy are really fundamental. So by network is optional, we don't mean that you don't have access to the network. Like, you can use your Wi-Fi, you can use your local network to access blockchain data, maybe get some your trades from centralized exchanges. What this means is that all the processing of this data happens locally on your machine. Data is not pushed to a remote server, it's not pushed to a remote API, everything happens transparently on your machine. So your local data is primary. Unlike all these clouds have, like using Google Drive, the primary source of data is Google Drive. Any copies if you have are usually some kind of cache, some secondary copy. And while it's unlike in the case of Google Drive, if your cloud provider goes out of business, then you might lose everything. Then, because everything is stored locally on your machine, it's more secure and it's harder to leak than if you had everything on a data center, because you are the owner, you control the machine, and you can actually better protect them. So let's talk about Rotkey. That's a nice project we are building. Rotkey is a portfolio tracker and accounting tool that is open source, local first, and it's focused on privacy. And unlike what some people believe, the Rotkey team is not only Lefteris. Like, we know he's kind of superhuman, but he cannot do everything on his own. Currently, the Rotkey team consists of 7 people, 6 developers, and 1 person handling operations. From the developers, we have Lefteris, which most of you, if not everyone, knows. Then he does backend, business development. He does a lot of stuff. Then I'm doing mostly front-end, back-end infrastructure, like I said. Then we have Zapin that handles also back-end. Luki is working with me on front-end, and he has been a really great help. And then we have Isaac and Alexi, which are our newest members that also do back-end. And finally, Selena, Lefteri's wife, that really helps us with the non-technical stuff that the company needs. And we are really glad to have her. We are building Rotkey across some 3 basic principles. Rotkey is open source, it's local first, and it uses encryption to store the data. With this, we can guarantee that the functionality is transparent. Like, you don't have to actually trust us. You can verify on how we handle your data and how the app works. Because it's a local app, you own the data. We don't have access to your data. We don't know anything about your data. Any address, any account, anything you put on Rotkey stays locally encrypted in the database in your machine. We don't have access to any of that. And also, you have access to the code. If anything happens to us, hopefully it will not, but if anything happens to us, someone can pick up the software and keep providing value to users. So let's talk about Rotkey's architecture. Rotkey is split into parts. One is the Python backend, and the other is the frontend. The frontend is really simple, just calls the backend, and it's what you see when you open the app. The backend does all the data processing. It calls open APIs, open nodes, or maybe you can also add your local nodes. So if you run your own Ethereum node, Rotkey can hit it, and it will be immensely faster than hitting public nodes. And then we have 2 databases. One is the encrypted user DB that uses SQL cipher to encrypt, and this is where your private data stays. And then we have the global DB that usually has ASCII information. The way we package Rotkey is a double way. So we have an Electron app that is available for macOS, Linux, and Windows, and we now support also ARM's Apple Silicon Macs. And then we have the Docker images, where you can deploy on a machine control and you can access it via web. Although you should be careful there because Rotkey was fortunately designed as a local app, so it would be better if you have a proxy in the front for security reasons. And then there is another way to run Rotkey if you own the DAppNode. There is DAppNode backup, and we are in close collaboration with DAppNode, which makes things really easier, and we want to improve the experience there. So, for example, we are working to make auto-configuring your local nodes in Rotkey automatic. Rotkey does portfolio tracking. At the moment, we support Ethereum, Kusama, Polkadot, Avalanche, Bitcoin Cash, and Bitcoin, along with a number of centralized exchanges and DeFi protocols. In the next release, we are doing work so that it makes it easier for us to support multiple EVM chains. So slowly we will start adding support for multiple EVM chains, starting with Optimism. In Rotkey, you can see your account history. Lefteris had a talk in Tuesday talking about how we do transaction decoding. Here you can see how this looks inside the app. In this example, you can see me basically migrating 400 sites to DAI and then selling them for 1.7 ETH from Kyber. Then we have accounting. Accounting in Rotkey is customizable. We try to be as general as we can so that we can support as many jurisdictions. You can parameterize how you generate your P&L report, and then you can export the CSV that you can pass to your accountant and do your tax report. Another great feature we have is Ethereum staking. You can see your staker's performance, you can see your daily stats, and you can see aggregated information about everything. And another part of Rotkey is insights. So we have graphs for statistics, although they are a bit problematic because we have to open the app every day so that we don't rely at the moment on chain history because that's quite hard, although we want to do that in the future. But at the moment we depend on snapshots, so you have to open the app every day so that the app can collect the snapshots. So this is important. Like, if you value your privacy, please run a full node. Like, it's really important for us. And, you know, like an easy way would be to, you know, get your dApp node, have your full node like running Gith or Erico or Nevermind, and then you can use TrueBlocks as an indexer because in Rotkey at the moment we have a problem. Because there is no easy way to get an account's transactions. We have to rely on Etherscan. And this can be problematic from a privacy perspective because Etherscan rate limits you. And you have to put an API key. And if you put an API key, you basically connect all your information, like your email address, your IP address, your accounts, and probably they have a good privacy policy, but you have to trust them for that because they are a closed source software. So the best idea would be to have something like TrueBlocks running, and TrueBlocks can index the chain and can detect a lot of these transactions, which can then fit to Rotkey. This way you could do a really privacy-focused portfolio tracking and accounting. Plus, as a bonus, you can actually, if you run Rotkey on dApp node, you can access your portfolio through the VPN locally in your mobile device. So that's, you know, like we met the user using Rotkey in such a way easy, and it was a really happy moment because we don't actually have any documentation on how to do that. So it was really nice. I just went a bit fast. So yes, so if you want to reach out, you can reach out through Discord. And please, really, like we build Rotkey for the community, we build it for us and for other people. So it would be nice if you give it a try. Like download the app, run it, test it, give us feedback. We always hear feedback, and the way we build the app is based on the user's feedback. So please do and let us know. Then you can follow the Rotkey app account on Twitter. Most of the times it's Lefteris tweeting from there. Not always. And you can also buy a premium subscription. It is a bit of support to us. It doesn't help us sustain the project, but it still helps us a lot. And with this, you can actually unlock the full Rotkey experience because the free version has some limitations. Yes, so I was a bit fast. But thank you very much.
Thank you, Gilsos. Do we have questions in the audience?
Hello. I'm liking a lot of these small projects, and I'm liking a lot of them. But I find them. How do you finance Rotkey? That's my question.
The funding.
Yeah, the funding. How is your? Are you in freedom to release a business model? Because at the end of the day, you all have to eat. I know you have to eat.
Yeah, exactly. So funding is really hard. Like I said, we currently have funding through Gitcoin grants, which is, I think, one of our biggest sources of support. And then Lefteris is trying to find ways so that we can get grants or integrating with different protocols. So these, I think, are our main ways of funding and paying salaries. Of course, it's as an open source project, we do it out of passion. So our salaries are not the best. Like we are below market rate. But it's something we love to do. So yeah, it's hard. And then we have the premium subscription, but at the moment our premium subscription is 10 euros per month. Which you can imagine how many users would want to be able to sustain the project out of this subscription model. You're welcome.
More questions? Oh, there is third row. This might have been covered in the presentation that you did. You said you rely on the transactions, but I assume you've looked at things like the graph, which is like more decentralized. What do you think about?
Yeah, so we use the graph, but in our use case, it's not a perfect fit because there is no unified model of the subgraphs. So for every protocol we support, we have to add a new subgraph, and this actually gives us a huge maintenance cost because we have to go and implement on our side the schema, handle every subgraph in a different way, and then as soon as a subgraph breaks, we have to fix it, communicate with people that are maintaining the subgraphs, and then we have to release a patch release to fix that for our users because the app is broken. And this is why we're trying to find a way that is more unified and more generic and that doesn't need the extra maintenance cost. Because the way the ecosystem works, new protocols pop up, and we have to support them because our users also want the support for these protocols. So it's really hard for us to go and implement its subgraph for its protocol. It becomes a maintenance hell for our small team.
Have time for more questions? Right. Thank you again, Kelsos.
Thank you.
And also, meet Kelsos outside of the room if you want to ask him anything later on. In about 5 minutes, we are going to hear a local talk about taxing crypto in Colombia by the head of the local tax authority, Luis Carlos Sarachis. So please be here 3 p.m. So at this point, we were supposed to have a talk about taxing crypto in Colombia. I have to apologize. We are still awaiting the speaker. So the talk might be postponed a couple minutes. It's going to end anyhow, like at 3:30. So everybody will be able to make it to the closing ceremony. But we're just asking for patience in case you came to see the talk. I didn't prepare any stand-up, so I can't really, entertain you in the meantime. Hey there. So since a few of you folks asked, we are still waiting for a speaker. So please, stay in the room. If he shows up, the talk is going to continue within the allocated slot, and afterwards we have the closing ceremony. But so far, I don't have any info about the arrival time, so sorry about that.
O de pronto... Hi.
Joseph, I'll be introducing you. I'll mention your name, ask you around, close down the stage, and you can come on. Hello, everybody. So we are back with our segment. The speaker has arrived. So next up, we are going to hear a talk on taxation of crypto in Colombia by the head of the Colombian Tax Authority, Luis Carlos Regis. So please, everybody, round of applause for the speaker.
Hi, everyone. I'm here to remind you that even though crypto isn't, and no type of crypto is currently a form of money in Colombia, that doesn't mean you don't have to pay taxes on it. That's a joke. Yeah, no, but even you know, because of this, we want to make sure that the rules for paying taxes on crypto and crypto-related activities are clear. We're taking steps to make that make things even clearer than they currently are. A few of you may have wondered, especially if you, even if you have just used a crypto platform, if you are, if you have to pay any taxes on the gains that you make from your investments, or if you run a platform. I don't know if representatives of the exchanges in the country are here. We would like to make sure that you know exactly what rules you have to follow. Briefly speaking, even though crypto is not legal tender in Colombia, it is considered for tax purposes an intangible asset, which basically follows the treatment that other jurisdictions give to crypto and in general to many digital assets. In Colombia, you have to you have to fill out a tax return as just a natural person. You have to declare your net worth, which is a very particular thing to the Colombian tax system. Many of you guys probably have heard the debate in Congress about taxation of your net worth, how it's calculated, and so just like if you're curious about this, you would basically have to tell us, to tell the tax administration the value of the crypto at the peso value that you acquired it on the day when you acquired it. You just have to tell us. There's currently no taxes on your net worth. There have been in the past, but this is only for informational purposes. And everything else is essentially capital gains taxation. If you buy crypto or other assets, right? If you buy an NFT and it increases in value, you don't have to pay any taxes until the moment when you sell it. So if you sell it, you make money on it. The difference between the price which you bought it and the price that you bought for it is the basis on which you have to pay a rate. That rate will depend on whether you have held the assets for 2 years or more. If you have held them for more than 2 years, this is the roughly speaking the capital gains tax. It's called ganancias ocasionales in Colombia. It's currently a 10% tax rate. If the tax reform bill that we're working on goes through, it will be at 15% of the appreciation. If you sell the asset before 2 years, then you just have to pay the ordinary rate, which is a progressive taxation scheme. It starts at 19%, and at very high levels of income, it goes all the way up to 39%, which is much like what you would pay in the United States for ordinary income as well. You may have wondered, I know because I have, if you're on an exchange and you buy and sell crypto, right, maybe you're just playing around with any type of cryptocurrency you've made, and you sell it to someone, right? And if you like to think about tax issues, which some people do, you may wonder, does this pay VAT, the value-added tax, IVA in Spanish? There are activities such as exchanges that do not pay VAT. So when it comes to intangible assets like crypto, then as long as they don't have an intellectual, commercial, industrial value, so this is more like patents, right? Like if they don't have that added value, then you're not responsible for paying VAT. However, if you're selling, say, at least some sort of NFTs, there may be VAT to be paid. So especially if you're thinking of running a business that operates buying and selling crypto, NFTs, other types of digital assets, these are things that you may want to take into account. And we want to make this easy for those paying taxes, right? You have to pay them. The least we can do is make it easy for you. So we are here to help. I've given instructions to the subdirectorate in charge of norms, interpreting the tax norms for specific cases and specific industries, to compile all the concepts we have issued about crypto in a single document. But also, we are here to collect the questions that you may have, and we want to issue an official concept about this. We want to do this both in Spanish and in English. We want to have clear rules for those coming from abroad to invest. And even though I think we're all excited for the closing event at 3:30, we are here to take questions. Yeah, sure.
Hello? Okay.
Hi. So you were mentioning that we would have to pay taxes if I, purchase a Bitcoin, let's say it goes up in price, and then sell it for fiat currency. But if I were to buy a Bitcoin and then swap it to another currency, another digital currency, let's say Ethereum, and the price was, technically created a taxable gain, how would I pay that tax? Would I pay it in the value of the local fiat currency? Would I pay it in one or the other intangible assets? How would you do that?
That's a great question. Because currently Ether and Bitcoin are not currently considered currency in Colombia, and you're just swapping assets, it may depend, but you would probably just have to pay the time you sold in your example, the Ethereum for fiat. And then I think that also raises the question of what do you do if you buy something in crypto, right? Like if you buy a house in crypto, like what would you do? How does it work? And then in that case, you would have to take into account the value at which that house is fairly valued and the value of your asset, and then that difference would be the basis for taxation.
You never specified whether it was first in, first out, which is if I had bought Bitcoin and maybe I put it off to the side for long-term storage or Ethereum, whichever asset, and then later I start trading with other assets over here. So first in, first out would say that the very first purchase of the asset, Ethereum, let's say, was at $100, and now it's at $1,500. It doesn't matter my trade's over here. It's first in, first out. Do you understand the first in, first out?
Right, right, yeah.
So you never specified whether there's a first in, first out rule that you have or not.
So I think what's really helpful for thinking all of this is that for all practical effects and purposes in Colombia, crypto assets are intangible assets. So you would handle, say, inventories in the same. You would follow the current accounting rules, right? And in Colombia, I don't know what accounting rules you're most familiar with, but we wouldn't be using US GAAP, but we would be using IFRS rules for accounting. So that's what would apply in this case. I think we probably in the concept and in the document that we will post. I will post it on my Twitter account to start clarifying some of those things, but mostly to invite questions like this so that we can give you specific, detailed answers. Yeah. Okay.
Hi. Oh. Hi. What about the crypto you gain, like paying on services? So, for example, I have an income on crypto. How do you tax that?
Yeah. Currently, you can be paid in things other than fiat in Colombia, and that's already regulated, right? You could be paid. So some people are paid in, or at least partly in education for their children, right? Like their firm pays their children's tuition, or they give them access to country clubs which have a certain value, and all those payments in basically in stuff, the same rules as for payments in income and in fiat apply. So you would basically have to tell the government what's the fair market fiat value of the crypto, and that would be the basis of the tax you pay. But you would pay exactly the same as if you were paying if you were being paid in fiat. So suppose you so you work for a company that's paying you in crypto, then they pay you and you tell the government this is how many pesos this was worth. Then you pay taxes on the basis of that, but then your crypto continues to gain in value. If you sell it to buy something else, then at the moment of selling it, you would pay an additional tax on those capital gains. Basically, yeah. And if you found someone who was willing to sell you stuff directly for crypto, then this follows the same. There are rules and regulations in Colombia that apply to exchanges of stuff, right? Like if you trade, I don't know, if you trade a house for 5 cars, which is something that people sometimes do, you would apply the same rules in the tax code. Permutas, se llama eso.
Some wallets have debit cards, given by Visa or MasterCard. So how do you make a chain of taxes whenever you have a wallet that lets you save in USDC or whatever, and then spend it in retail, let's say in a cafe? I think there will be taxes along the way, but who is paying what in that chain?
So I'm sorry, the question is you have
I don't have one, just
okay, yeah. More of a comment, yeah.
Hypothetically, there is a wallet with debit cards. So how do they pay taxes along the way when you have debit cards, the payment processors, and there is a crypto wallet involved?
Right. Yeah, currently none of that. So those are things that would have to be regulated by the financial authority, the Colombian SEC, the Superintendencia Financiera. Because the regulation is still to come, you would basically not pay a lot of things that you pay in the current financial system. There's, you may be aware that in Colombia there's the 4 por mil, which is like a 0.4% tax on financial transactions. That would apply only when you convert that into into fiat and into the traditional financial system. But that's a great idea to raise revenue. I'll take that one with me. Yeah. I'm just kidding. But not entirely. Yeah.
What's your position about using any cryptocurrency as a collateral to have pesos or US dollars? How do you deal with it?
As a collateral, like for getting a loan or?
Yes, exactly.
This is still something that has to be regulated by the financial authority. I suppose you could sign a private contract and then you give this as a collateral as long as someone else accepts it. You could sign a contract that specifies it, right? Yeah. Right. Okay. So in the case of DeFi, yeah, we're actually, this is one of the questions that we currently want to address in detail because it's a question that we've been we're being asked a lot. So we're working on issues related to DeFi for sure. Yeah.
Hi, your office here. Your office published a document like 4 months ago, the former director, regarding these taxes on crypto. That document is still running? We have to apply that?
It's still in force. There were roughly 25 documents that we had published answering various questions. So what we're doing is we're compiling all of them in a single document so that you have everything in one source, but nothing has changed. We just want to make this more accessible. And like I said, some of these, these questions and more, if you guys want to, talk to the two lawyers from the end that came here with me, we will make sure to address them. We want to give to have a comprehensive treatment of how to handle these tax issues to give to give everyone more certainty and stability, and hopefully not have to pay like very expensive consultants when we can do it for free for you. Yeah.
The context of my question is because the former director said in Caracol Noticias that people that needs to declare their crypto, they have to do it from 2017, and they have to pay the multas from those years, 17, 18, 19, 20. And what do you think about that? Because the incentives are maybe not aligned, and people don't want to declare something to be a bad person and paying those multas, you know?
Right. As part of the tax reform bill that we are, shepherding through Congress, we are trying to make a lot of those fines, not just for crypto specifically, but for a lot of different businesses and also just regular people, a lot more understanding of when people are not really at fault, and we want to focus on actual tax evaders. The process is still ongoing, so as I said, we welcome all feedback that you may have about the provisions that we have already included in the bill and what else could be useful. One thing that we have gotten a lot of questions about has to do with whether we will accept taxes in crypto. It's something that we as a tax administration can do if given legal authority by Congress. We can handle it. We think it's actually very interesting if if a firm or if a person wants to be associated with a specific wallet or sets of wallets, because that actually, as you guys know, a lot of people still think that crypto is cryptic and that you can't trace stuff. We're actually interested in the traceability of a lot of the cryptocurrencies, and that can only be good for us as a tax administration. So we're very open to all of these proposals. Talk to your congressman or congresswoman. There's still time to introduce some provisions here.
So two questions. The first one is, we've talked about a lot of taxes, right? But what's your truly vision about crypto? Like, would you be considered as a pro-crypto person, or what are you a detractor? That's one. And the other one, which is more question that I always ask, do you hold any crypto?
Do I what?
Do you hold any crypto?
I've held it, yes. Woo! Yeah. Oh no, for sure. I mean, look, I think it's a technology that's here to stay. I think it's promising. I think there's a lot of misconceptions about crypto. I think we should help everyone understand that this is a promising technology. I look forward to the forthcoming regulation that various other government agencies, or which I have no control, I should say that, will issue at some point. I think it should be sooner rather than later. I think there's one of the developments that I find most exciting is central bank issued digital currencies. I was excited, like I suppose many of you were, when the central bank announced that they are studying the issue. I think only good things can come from this industry. Yeah.
Okay, I have another question.
Okay.
So it's more about stable coins and USDT, USDC. So if I get my pesos and always convert them into US dollars, or well, in this case, USDC or USDT, and then when I need the money back in Colombia, I transfer them back to my account, what would be the tax incentive, like implications there? Because you said, like, it's like buying dollars in una caja de cambio and then just like either spending it abroad or just having them in your house or whatever. So what would be the implications there?
Yeah, so something like USDT or other stable currencies, stable coins they are not legal tender here or anywhere. So they are under Colombian legislation and rules. They are considered just intangible assets. So the way it would work is, suppose you buy, I don't know, you go through a whole process, right? You deposit some pesos into a local platform. You use it to buy Bitcoin, which then in a local platform, which then you transfer to a platform abroad, and you use it there to buy some USDT, and then you do some more stuff with it, and then you bring it back. The way it would work in terms of it being taxed is there's a certain amount in pesos that you paid at the exchange rate, the official exchange rate of that day, the Ethereum, tasa representativa del mercado. And then when you transform it back into pesos at the very end, it's the difference between the pesos you got at the very end and the peso value of the original asset. That would be the capital gains, so to speak.
Hello. Hi. Here.
Yeah, okay.
You've stated your position very clearly about the crypto coins and all these coins that are natively digital, but there are also other type of tokens that represent, for example, real life assets, such as houses and other kind of things. Is your take the same for those types of assets that have a real asset, like as an underlying value, in real life, but they're just represented digitally?
I like the technology. Look, I just run the tax administration. Like, those are issues for the for various government entities, right? Like, I think it's exciting to see how ownership registries would work, how the financial regulation really is what, as we all know, is necessary for this industry to have a more solid footing. I do hope, and I know that the people involved in this understand the issue, and they're working towards making things like that possible. I think in general it's an exciting technology, and I also think that we're still trying to figure out all the possible ways in which the technology can be used. So I'm sure there's more to come, and those are good examples of what we could see. Oh, the taxation. Okay. So when you have underlying assets, in that case, yeah, basically the difference between the peso price when you invested and the peso price when you finally sold it, that's what will be taxed, and it will be taxed as either capital gains or ordinary income, meaning ganancias ocasionales o rentas no laborales. Yeah.
You mentioned the CBDC, and there is an incentive for the tax authority to look everything that the citizens do for tax purposes in that sense. What do you think, what is your position about the privacy of the citizens? What is the balance between knowing and taxing what they do and knowing a lot more that you need to know?
I think that's a question for Colombian society to answer as a whole. I'm going to be perfectly honest. From the point of view of the tax administration, we're interested in the traceability of transactions, especially given that the Colombian economy is so informal and so many people use cash. I think, for instance, if we could offer people a digital currency that is more convenient than cash, even safer than cash, right? Like if someone steals cash from you, there's no way of getting it back. If it's highly traceable, you may be able to know what happened to it afterwards, right? So I think there are trade-offs in life, and I think it would be particularly interesting for everyone involved to have a digital currency that is not 100% anonymous, that can be traced, but that also offers extra safety beyond the safety that cash can give you. Yeah, I think my time is up, and we probably all want to go out there. But thank you for your questions. Alfredo and Estefania are here to collect some more of those. If you yeah, we will be collecting them and publishing an official document answering them. So make sure to ask absolutely everything that you want to ask. And this is not the only, yeah, like they will be happy to share contact information with you so that we can maybe set up a round table between Diane and the industry and start clarifying some of these questions. Thank you very much.
Hey guys, I think this is going to be at the end of this room. Please feel welcome to go to the main stage. We're going to have some very cool closing event for you. Thank you very much. Goodbye.